Jakarta persistence architecture. This is the architectural diagram of Jakarta persistence. Jakarta persistence, JPA, formerly Java Persistent API, is a Jakarta EE application programming interface specification that describes the management of relational data in enterprise Java applications. This diagram illustrates the relationships between the primary components of the architecture. Note, a number of depicted interfaces are only required outside of an EJB3 compliant application server. In an application server, EntityManager instances are typically injected, rendering EntityManagerFactory unnecessarily. Also, transactions within an application server are handled using standard application server transaction controls. Thus, the EntityTransaction also goes unused. Persistence. The jakarta.persistence class contains static helper method to obtain an EntityManagerFactory instances in a vendor neutral fashion. EntityManagerFactory, the jakarta.persistence.EntityManagerFactory class is a factory for entity managers. EntityManager, the jakarta.persistence.EntityManager is the primary interface used by the applications. Each entity manager manages a set of persistent objects and has APIs to insert new objects and delete existing ones. When used outside the container, there is one-to-one relationships between EntityManager and EntityTransaction. EntityManagers also act as factories for query instances. Entities are persistent objects that represent data store records. EntityTransaction, each entity manager has a one-to-one relation with single jakarta.persistent.EntityTransaction. Entity transactions allow operations on persist data to be grouped into units of work that either completely succeed or completely fail, leaving the data store in its original state. These all or nothing operations are important for maintaining data integrity. A query, the jakarta.persistence.query interface is implemented by each vendor to persistent object that meet the certain criteria. Jakarta Persistent standardizes support for queries using both JPQL and structured query language. You can obtain query instances from an entity manager. So here you can see EntityManagerFactory, Entity Manager, the entity transaction, query, and persistence are inside jakarta.persistent. Entity Manager can have many Entity Manager can have many entity managers. Entity Manager have one entity transaction, and Entity Manager can have many queries, and you can see here persistent, and Entity Manager can have many entities. And here EntityManagerFactory is connected to Entity Manager, and Entity Manager is connected to Entity Transaction, Query, and Entity. Here you can see another view of JPA architecture. Here the entity. An entity is a persistent domain object. Each entity represents a table in a relational database. An entity instance corresponds to a row in a table. In that table, JPA use annotations for or XML to map entities in a relational database. But the persistent states of an entity fields or properties, setter or and getter methods use object or relational mapping annotations to map the entities and entity relationships to the relational data in the underlying data store. Persistent unit. A persistent unit defines a set of all entity classes that are managed by EntityManager instances. Instances in an application. This set of entity classes represent the data contained within a single data store. Persistent units are defined by persistence.xml configuration file. JPA uses persistent.xml file to create the connection and set up the required environment. Provides the information which is necessary for making database connections. Persistence class contains Java static methods to get EntityManagerFactory instances. Since JPA 2.1, you can generate database schemas or tables or create DDL scripts as determined by the supplied properties. EntityManagerFactory class is a factory for entity managers. During application startup time, the EntityManagerFactory is created with the help of persistence unit. Typically, EntityManagerFactory is created once, one EntityManagerFactory object per database, and kept alive for later use. EntityManager is an instance to perform actual database interactions. Creates persistent create persistent instance to remove persistent instance. Find entities by entity primary key. Allows queries to be run on entities. Persistence context. A persistent context handles a set of entities which hold data to be persistent in some persistent store, for example, database. Each entity manager instance is associated with the persistence context. EntityTransaction. A transaction is a set of operations that either fail or succeed as a unit. A database transaction consists of a set of SQL operations that are committed or rolled back as a single unit. Any kind of modification initiated via EntityManager object are placed within a transaction. An EntityManager object helps creating an entity transaction. Query is an interface and used to control query execution. EntityManager object helps creating a query object. The implementation depends on persistence provider. Criteria API which supports to build SQL queries using Java objects, so that with the JPA criteria API it's possible to have type safe queries that can be checked at compile time. Here persistence creates EntityManagerFactory. EntityManagerFactory is configured by persistence unit. Here EntityManagerFactory creates EntityManager. EntityManager creates EntityTransaction. EntityManager creates query, and EntityManager creates criteria. EntityManager manages entity. Here you can see Java persistence in the Java EE environment. Here we are considering EJB 3.0 and Java Persistence API 1.0 in this context. After years of complaints about complexity of building enterprise application with Java, ease of development was the theme for Java EE5 platform release. EJB 3.0 led the change and found ways to make enterprise Java beans easier and more productive to use. In the case of session beans, the message-driven beans solution to usability issues were reached by simply removing some of the onerous implementation requirements and letting components look more like plain Java objects. In the case of entity beans, however, a more serious problem existed. If the definition of easy of use is to keep implementation interfaces, the descriptors out of application code, and to embrace the natural object model of the Java language, how do you make coarse-grained, interface-driven, container-managed entity beans look and feel like a domain model? Answer was to start over and leave the entity beans alone and instead produce a new model for persistence. Java Persistent API was born out of the recognition of the demands of practitioners and existing proprietary solutions that they were using to solve their problems. To ignore that experience would be folly. Thus, the leading vendors of object relational mapping solutions came forward and standardized the best practices represented by their products. Hibernate and Toplink were the first to sign on with EJB vendors, followed by later JDO vendors. Years of industry experience coupled with the mission to simply develop combined to produce the first specification to truly embrace the new programming model offers by the Java C5 platform. The use of annotations in particular resulted in the new way of resulting persistent in applications. That had never been seen before. The resulting EJB3 specification released in 2006 ended up being divided into 3 distinct pieces and split across 3 separate documents. First document contains all the legacy EJB components model content, and the second one described the new simplified POJO component model. The third one was the Java Persistent API, a standalone specification that described the persistent model in the both the Java SC and Java EE environments. This shows Java Persistent in the Java EE environment. Here you can see the client interacts with the session bean. Session bean, JPA, and DB are inside the application server. Session bean interacts with JPA. Entity is inside persistent provider. Persistent provider is inside JPA. JPA interacts with DB. Here you can see a Jakarta persistence ORM architecture. The largest part of an API that persists object to relational database ends up being object relational mapping component. The topic of ORM usually includes everything from how the object states is mapped to a database columns, how to issue queries across the object. We are focusing here how to define and map the entity state to the database, emphasizing the simple manner which it can be done. Most important ORM features are idiomatic persistence by enabling to write the persistent classes using object relational by using object oriented classes. High performance by enabling fetching and locking techniques. The last feature is reliable by enabling stability for Jakarta persistence programmers. This figure shows the Jakarta persistence ORM architecture. Here you can see the object, Pojo class and DAO service class are inside the object here. Object is connected to server scope ODG, object grid, persistent loader, mapping ORM.xml, persistent provider and mapping are inside the server scope ODG. Server scope ODG is connected to relational DBs. Here you can see layers of caching in Jakarta persistence. If there is one thing we can, now we are going to shorten through caching the layers. If there is one thing that we software types like to do, it is a break things down into layers. We do this because dividing a complex system into multiple cohesive pieces helps us to more easily understand and communicate aspects of the system. Because it works pretty well, and we are not ones to ignore a good thing. We will similarly partition the Jakarta persistent architecture into layers to illustrate component different opportunities to cache. This figure gives a pictorial view of different caching layers that might exist. First layer we encountered is actually the application tier. Any application might be written to cache as many entities as it liked, simply by holding into references to them. This should be done with the realization that entities are likely going to become detached at some point, and the longer they sit in application space, the higher probability they will become stale. Application caches have their place but are generally discouraged because the cached entity instances will never be included in any future Jakarta persistent query results or persistent context. Next, the persistent context referenced by the entity manager can be considered cache because it keeps references to all managed entities. If as it is done in hardware architectures, we categorize the different layers of caching into levels. We would call the persistent context at first revealing Jakarta persistent caching because it is the first place that the persistent provider could retrieve in an in-memory entity form. When running in a transaction scoped entity manager that has a persistent context demarcated by the transaction boundaries, the persistence context can be termed a transactional cache because it is around only for duration of the transaction. When entity manager is an extended one, its persistent context cache is longer lived and will go away only when the entity manager is cleared or closed. Executing find method or query method can be thought as loading one or more entities into the cache while invoking detach method on the entity that can in some ways be considered the persistent context cache eviction of that entity. The difference is that if there are pending state changes in that entity, they will lost unless a flush operation occurs before entity is detached. Caching in Entity Manager caching in EntityManagerFactory is referred to by some as the second level cache, but of course this name makes sense only if there are no caching layers between it and the persistent context, which is not the case for all providers. One thing that is fairly prevalent across all providers is that the entity data in this cache is shared across entity managers from the factory that contains the cache. So the better name for it is shared cache. This cache has a specific API associated with it and is the last cache that can contribute entity state to Jakarta persistence is the JDBC cache drive. JDBC driver cache. Most drivers cache connections and statements. Some caches keep the track of the table or column state that is essentially transparent to the Jakarta persistent provider, but that nonetheless can offer some saving in terms of not having to go to the database to get data on every call. This is generally feasible on the driver only if it is known that either data is read-only or driver controls the database access exclusively. Note some providers such as Eclipse, Link, and Jakarta persistent compatible implementation provide much more sophisticated and exotic caching layers and features such as isolated caching or virtual private database VPD, support line gain options to determine automatic entity eviction policies and distributed cache coordination mechanisms. Many also offer integrations with deluxe and highly specialized distributed caching products. To see how various levels of caching in the system get accessed during the course of typical operation, you can see the you can go through some code segment with find requests. To see how the various levels of caching in the system get accessed during the course of typical operation, trace a find request for the employee ID with ID 100. First thing that happens is that the client looks in its total cache, local cache for the employee and finds that it doesn't have the employee instance with ID 100. Then it issues the find calls to the entity manager. The entity manager will likely have the persistence as context associated with it. So it checked its persistence context for the entity of type employee with ID 100. If the entity exists in the persistence context, the managed instance is returned. If it does not exist or no persistent context had yet be associated with the entity manager, the entity manager goes to the factory we'll go to the factory to see if its if the shared cache has the entity instance. If it does, the new employee instance with ID 100 is created from the shared one and inserted into the persistence context, and the new managed instance is returned to the caller. And if it does not in the shared cache, then an SQL query is generated to select the entity from the database. The JDBC driver may have some data cache, so it could short circuit the select clause and return at least part of the nested needed data. The resulting query data is then composed into an object and passed back. The object is inserted into the shared EntityManagerFactory cache, and a new instance copy of it is created and inserted into the persistent context to be managed. That entity instance is finally returned to the client application for the client to cache if it is so inclined. So here you can see the application cache is inside application, and application interacts with Entity Manager and EntityManagerFactory. Persistent context is inside Entity Manager, and Entity Manager interacts with EntityManagerFactory. Shared cache is inside EntityManagerFactory, and EntityManagerFactory interacts with JDBC driver, and table or column caching is inside JDBC driver. JDBC driver interacts with database. Now we are considering here you can see the generation process in packaging and deployment. There are number of different aspects of schema generation that can be applied independently in combination with each other. Before we dive into them, we go over some concept of schema generation and the basics process, so that you can get and feel what is happening. Then in here, schema generation is done by a part of a persistence provider. That we'll call the generation processor. This processor is responsible for taking some inputs and generating one or more outputs. The inputs can be either application domain objects or persistence DDL. DDL scripts accessible to processor, either package within the application or a referenceable from it. The output will be DDL that is either executed in the database by the processor or written to script files. This figure shows the simple view of the processor. The schema generation process will typically happen either when the application is deployed, for example, when in a container, or when the EntityManagerFactory gets created on a persistent.create factory manager factory. Create EntityManagerFactory method invocation in Java SE. There are three distinct operations supported by schema generation. You can create the schema objects. Drop the schema, delete the schema objects, or preload preload data into the schema. Although the create and drop schema operations are specified within the same property, you can also mix and match which operations you want to executed. The order in which they will be performed going to dictated by what is sensible. For example, if all three are specified, the old schema will be dropped, the new one will be created, and then the data will be preloaded. To control the inputs and outputs and what occurs during the schema generation processing, the number of standard properties can be specified either statistically in the persistent.xml file or dynamically in runtime call in Java SE to persistent.create EntityManagerFactory method or persistent.generate schema method. Properties accessed at the runtime will override properties defined in the persistent.xml file. Here you can see a project directory structure in here, sample project directory structure. This is this is a crude example. This is sample crude example. Here the under JPA crude example settings, dot settings directory, src target directory, and are there, and classes and files dot class path dot project and pom.xml are here in this example, and under source under src main and test directories are here. Under main Java and resources directories are here. Under Java meta info and net directories are there, and persistence.xml are inside meta inf. Under here Java guides are inside net, and Hibernate is inside Java guide, and entity and util are inside Hibernate, and app.java and app.java and crude operations.java inside Hibernate here, and student.java is inside entity, and jpa util.java is inside util. Now we are focusing on jakarta.persistence. Jakarta persistence is the API for the management for persistence and object relational mapping. Here you can see the relationships between Jakarta persistence concepts. In fact, separate API calls are needed to perform many of the operations on entities. This API, here the Entity Manager, this API is implemented by EntityManager and encapsulated almost entirely within a single interface called jakarta.persistence.EntityManager. When when all is said and done, is it to an entity manager that the real work of persistence is delegated. Until an entity manager is used to actually create, read or write an entity, and entity is nothing more than a regular non-persistent Java object. When an entity manager obtains a reference to an entity, either by having explicitly passed in as an argument to a method call, or because it was read from the database, that object is said to be managed by the entity manager. The set of managed entity instances within an entity manager at any given time is called a persistent context. Only one Java instance is with the same persistent identity may exist in the persistent context at any time. For example, if an employee with an persistent identity or ID of 158 exists in the persistent context, then no other employee object with its ID set to 158 may exist within the same persistent context. Entity managers are configured to be able to persist or manage specific types of object, read and write to a given database and be implemented by a particular persistent provider, or provider for short. It is the provider that supplies the backing implementation engine for the entire Java persistent API from the Entity Manager through to an implementation of the query classes and SQL generation. All Entity Managers from the factories of type jakarta.persistence EntityManagerFactory. The configuration for Entity Manager is templated from the EntityManagerFactory that created it, but it is defined separately as a persistent unit. A persistent unit dictate either implicitly or explicitly the same setting, the settings and the entirely classes used by all entity managers obtained from the unique EntityManagerFactory instance bound to the persistent unit. There is therefore a one-to-one correspondence between persistent unit and its concrete EntityManagerFactory instance. Persistent units are named to allow the differentiation of one EntityManagerFactory from another. This gives the application control over which configuration of persistence unit is to be used for operating on a particular factory. This figure shows for each persistent unit there is an entity manager factory and many entity manager factories can be created from a single entity manager factory. The part that may come as a surprise is that many entity managers can point to the same persistent context. We have talked only about the entity manager and its persistent context, but there may be in fact multiple references to different entity managers, all pointing to the same group of managed entities. This will enable the control flow to traverse container component but continue to access the same persistent context. Here you can see the relationships between Jakarta persistence concepts. Here they note that while some are actual API objects, others are only abstract concepts that help explain how API works. The persistence API object is persistence description class used to obtain an entity manager factory. Entity manager factory API object entity manager factory configured factory object used to obtain entity managers. Persistence unit named configuration declaring the entity class and the data store info. Entity manager API object entity manager and main API object used to perform operations and queries on entities. Persistent context set all entity instances managed by specific entity manager. Here you can see relationships between Jakarta persistence concept. Persistence context create entity manager factory. Entity manager factory create entity manager. Entity manager factory configured by persistent unit. Entity manager manages persistent context and persistent context is connected to persistent unit creates a persistent context. One persistent context can have many entity manager factory and one entity manager factory have one persistent. Entity manager factory have many entity managers and entity manager can have one entity manager factory. Entity manager factory have one persistent context and persistent context can have many entity managers. Many entity managers. In persistent context has one persistent unit. Persistent unit can have many persistent context. and EntityManagerFactory has a persistent unit, and persistent unit has EntityManagerFactory. As an example, we can consider jakarta.persistent package. Jakarta persistence is the API for the management for persistent and object relational mapping. This is in module jakarta.persistent. As an exception example, we can consider class persistence exception thrown by the persistent provider when a problem occurs. All instances of persistence exception, except for instances of no result exception, non-unique result exception, lock timeout exception, and query timeout exception, will cause the current transaction if one is active and the persistence context has been joined to it to be marked for rollback. This is in module jakarta.persistence in package jakarta.persistence. As an error example, we can consider this. This occurred in the environment with Spring Boot, JP, and Olingo. An attempt was made to call a method that does not exist. The attempt was made from the following location: org.hibernate.cfg.annotation binder.bind join table association. The following method did not exist: java x.persistent.join table.indexes, etc. An action: correct the class path of your application so that it contains a single comparable version of java.persistent.join table. Now we are focusing on EntityManagerFactory. The jakarta.persistence.EntityManagerFactory class is a factory for entity managers. The EntityManagerFactory interface is used by the application to obtain an application manage entity manager. When the application has finished using the EntityManagerFactory and/or at application shutdown, the application should close the EntityManagerFactory. Once an EntityManagerFactory has been closed, all its entity managers are considered to be in the closed state. As an example, we can consider interface EntityManagerFactory. Interface used to interact with the EntityManagerFactory for the persistence unit. When the application has finished using the EntityManagerFactory and/or at application shutdown, the application should close the EntityManagerFactory. Once an EntityManagerFactory has been closed, all its entity managers are considered to be in the closed state. This is in the module jakarta.persistence and in the package jakarta.persistence. As an example 2, we can consider this code segment. The following example illustrate the creation of EntityManagerFactory in Java SE environment and its use in creating and using resource local entity manager. Here the persistent class is a bootstrap class that is used to obtain an EntityManagerFactory in Java SE environment. It may also be used to cause schema generation to occur. Here you can see the create EntityManagerFactory method with This method creates and return an entity manager factory for the named persistent unit. Here the parameter persistent unit name, the name of the persistence unit. Here you can see the entity manager factory interface used to interact with the entity manager factory for the persistent unit here. Here you can see create entity manager method, create a new application manage entity manager. This method returns a new entity manager instance each time it is invoked. The isOpen method will return true on the returned instance. Here you can see the close method. Close the factory, releasing any resources that it holds. After a factory instance has been closed, all methods invoke on it will throw the illegal state exception except for isOpen, which will return false. Once an entity manager factory has been closed, all its entity managers are considered to be in the closed state. Now we are considering a entity manager factory interface as an example. Entity manager factory interface in entity managers and persistent context. The entity manager factory interface is used by the application to obtain an application manage entity manager. The interface entity manager factory in package jakarta.persistence in module jakarta.persistence interface used to interact with the entity manager factory for the persistent unit. The entity manager factory interface is used by the application to create an application manage entity manager. Each entity manager factory provides entity managers instances that are all configured in the same manager. For example, configured to connect to same database, use the same initial settings as defined by the implementation, etc. More than one entity manager factory instances may be available simultaneously in the JVM. Methods of the entity manager factory interface are thread safe. Now we are considering obtaining an entity manager factory. For example, here within Jakarta EE environment, an entity manager factory can be injected using persistent unit annotation or obtained through JNDI lookup. The unit name element may optionally be specified to designate the persistent unit whose entity manager factory is used. For example, here you can see the obtaining an entity manager factory in Java SC environment, for example. Outside a Jakarta e-content environment, the jakarta.persistence class is the bootstrap class that provides access to an entity manager factory. The application creates an entity manager factory by calling the create entity manager factory method of the jakarta.persistence class. For example, here now we are considering references to entity manager and entity manager factory in metadata annotations. Here we consider persistent context annotation. Properties that are not recognized by a vendor must be ignored. Here the persistent context Annotation is used to express a dependency in a container entity manager. And its associated persistent context. The name element refers to the name by which the entity manager is to be accessed in the environment referring to the context, and is not needed when the dependency injection is used. The optional unit name element refers to the name of the persistent unit. If the unit name element is specified, the persistent unit is for the entity manager that is accessible in JNDI must have the same name. Type element specified whether a transaction is scoped or extended persistent context is to be used. If the type element is not specified, a transaction is scoped persistence context is used. Synchronization type element specify whether the persistent context is always automatically synchronized with the current transaction, or whether the persistent context must be explicitly joined to the current transaction by means of the entity manager join transaction method. Optional properties element may be used to specify properties for the container or persistent provider. Properties defined by this specification must be observed by the provided vendor. Specific properties may be included in the set of properties and are passed to the persistent provider by the container when the entity manager is created. Properties that are not recognized by the vendor must be ignored. Persistent context annotation declares one or more persistent context annotations. It is used to express dependency on multiple persistent contexts. As an example, we can consider illegal state exception. If the EntityManagerFactory has been closed, in method EntityManager create EntityManager in interface EntityManagerFactory. As an error example, we can consider this error occurred in the environment with Spring Data 2.6.1 with Eclipse link and Jakarta 3. Java.land.no class def found error. Java X persistence entity manager factory at org.spring framework.data.jpa.util bean definition utils etc. Now we are focusing on Entity Manager. The jakarta.persistence.EntityManager is the primary JPA interface used by applications. An Entity Manager instance is associated with the persistence context. A persistent context is a set of entity instances in which, for any persistent entity, identify there is a unique entity interface, entity instance. Within the persistence context, the entity instances and their lifecycle are managed. The Entity Manager interface defines the methods that are used to interact with the persistence context. The Entity Manager API is used to create and remove persistent entity instances, to find persistent entities by primary key, and to query over persistent entities. As an example, we can consider interface Entity Manager. Interface used to interact with the persistence context. An Entity Manager instance is associated with a persistent context. A persistent context is a set of entity instances in which, for any persistent entity identified, there is a unique entity instance. Within the persistence context, the entity instances and their lifecycle are managed. The Entity Manager API is used to create and remove persistent entity instances, to find entities by their primary key, and to query over entities. The set of entities that can be managed by a given Entity Manager instance is defined by a persistent unit. A persistence unit defines the set of all classes that are related to or grouped by the application, and which must be located in their mapping to a single database. This is in module jakarta.persistence and package jakarta.persistence. As an example, we can consider this code segment. This is an example of use of Entity Manager API. Here, annotation type persistence context expresses a dependency on a container managed Entity Manager and its associated persistence context. Here you can see Entity Manager interface used to interact with the persistence context. Here you can see the find method, find by the primary key, search for an entity of the specified class, and primary key. If the entity instance is contained in a persistent context, it is returned from there. And this is entity class, the parameter, and this is primary key. Here you can see a persist method, make an instance managed and persistent. Here you can see the parameter entity instance here. Now we are considering Entity Manager interface in Entity Manager in Entity Operations. Interface Entity Manager in package jakarta.persistent in module jakarta.persistence. Interface used to interact with persistence context. Find method, provided it is invoked without lock or invoked with lock mode type none, and get referenced method are not required to be invoked within a transaction. If an entity manager with transaction is called persistent context is in used, the resulting entities will be detached. If the entity manager with extended persistent context is used, they will be managed. the query, type query, stored procedure query, criteria builder, meta model, and entity transaction objects obtained from an entity manager are valid while that entity manager is open. If the argument to the query create query method is not a valid Jakarta persistent query string or valid create criteria query object, the illegal argument exception may be thrown, or the query execution will find and the persistent exception will be thrown. If the result class specification of a Jakarta persistent query language query is incompatible with the result of the query, the illegal argument exception may be thrown when the create query method is invoked, or query execution will fail and persistent exception will be thrown when the query is executed. If the native query is not a valid query for the database in used, or if the result set specification is incompatible with the result of the query execution will fail and the persistent exception will be thrown when the query is executed. The persistent exception should wrap the underlying database exception when possible. Runtime exception thrown by the method of the entity manager interface, other than the locked timeout exception, will cause the current transaction to be marked for rollback if the persistent context is joined to that transaction. Method clause is open, join transaction, and get transactions used to manage application, manage entity managers and their lifecycle. Entity manager interface and other interfaces defined by this with the specification contain method that take properties and or hint as argument. In the specification distinguishes between properties and hints as follows. A property defined by the specification must be observed by the provider unless otherwise explicitly stated. Hint specify a preference on the part of the application, while a hint defined by this within the specification should be observed by the provider if possible. A hint may or may not always be observed. A property application must not depend on the observance of a hint. Now we are considering obtaining an entity manager in the Jakarta EE environment. In entity managers and persistence, obtaining an entity manager. For example, here, a container managed entity manager is obtained by application through the dependency injection or through the direct lookup of the entity manager in the JNDI namespace. The container manages the persistent context lifecycle and the creation of the closing of the entity manager instance transparently to the application. Persistent context annotation is used to enter entity manager injection. The type element specify the whether a transaction is scoped or extended persistent context is to be used. The synchronization element specify whether persistent context is always automatically joined to the current transaction. The default or is not joined to the current transaction unless the join transaction method is invoked by the application. The unit name element may optionally be specified to designate the persistent unit whose entity manager factory is used by the container. The semantic of the persistent context synchronization type of there are types. For example, here the entity manager example, JNDI lookup of an entity manager is illustrated here. Now we are considering JT entity managers in controlling transactions. An entity manager whose transactions are controlled through the JTA is a JT entity manager. In general, JT entity manager participates in the current JTA transaction, which began and committed external to the entity manager and propagated to the underlying resource manager. Now we are considering a local resource local entity managers. An entity manager whose transactions are controlled by the application through the entity transaction API is a resource local entity manager. A resource local entity manager transaction is mapped to the resource transaction over the resource by the persistent provider. Resource local entity transaction, local entity managers may use server or local resources to connect to the database and are unaware of the persistence of the JTA transaction that may or may not be active. As an example, we can consider entity exist exception. If the entity already exists, the entity exist exception may be thrown when the persistent operation is invoked, or the entity exit exception or another persistence exception may be thrown at flush or commit time in method void persist object entity in interface entity manager. As another example, we can consider this no persistence provider for entity manager named error when trying to create EntityManagerFactory in an environment with Eclipse Dynamic Web Project and MariaDB using Hibernate ORM. No persistent provider for entity manager named persist unit. jakarta.persistence.create EntityManagerFactory, etc. Now we are focusing on entity transaction. Each entity manager has one-to-one relation with a single jakarta.persistence.EntityTransaction. The entity transaction interface is used to control resource transaction on resource local entity managers. The EntityManager.getTransaction method returns an instance of the entity transaction interface. As an example, we can consider interface entity transaction. Interface used to control a transaction on resource local entity managers. The EntityManager.getTransaction method returns the entity transaction interface. This is in module jakarta.persistence and package jakarta.persistence. As an example too, we can consider this code segment. The following example illustrate the creation of an entity manager factory in a Java SE environment, and it's used in creating and using resource local entity manager. We are considering this here entity transactions. Here you can see the get transaction method returns the resource level entity transaction object. The entity transaction instance may be used serially to begin and commit multiple transactions. Here you can see a begin method in interface entity transaction. This starts a resource transaction. Here you can see a commit method. Commit the current resource transaction, writing any unflushed changes to the database. Now we are considering entity transaction interface in entity managers and persistence context with regard to controlling transactions. If the entity transaction commit operation fails, the persistent provider must roll back to the transaction. The interface entity transaction in package jakarta.persistence in module jakarta.persistence. Interface is used to control transactions on the resource local entity managers. The EntityManager.getTransaction method returns the EntityTransaction interface. The EntityTransaction interface is used to control resource transaction on resource local entity managers. The EntityManager.getTransaction method returns an instance of the EntityTransaction interface. When the resource local entity manager is used, the persistent provider runtime throws an exception defined to cause transaction rollback. The persistent provider must mark the transaction for rollback. If the transaction.commit operation fails, persistent provider must roll back the transaction. Now we are considering persistence context lifetime and synchronization type in entity operations. Synchronization with the current now we are considering synchronization with the current transaction. By default, the container managed persistent context is of synchronization type .synchronize and is automatically joined to the current transaction. Enum synchronization type in package jakarta.persistence in module jakarta.persistence specify whether the persistent context is always automatically synchronized with the current transaction or whether the persistent context must be explicitly joined to the current transaction by the means of the EntityManager.joinTransaction method. By default, a container managed persistent context is of synchronization type .synchronize and is automatically joined to the current transaction. A persistent context of a synchronization type .unsynchronized will not be enlisted in the current transaction unless the EntityManager join transaction method invoke. By default, an application managed persistent context is associated with the JTA entity manager and that is created within the scope of an active transaction is automatically joined to the transaction. An application managed JTA persistent context that is created outside the scope of a transaction or an application managed persistent context of type synchronization.unsynchronized will not be joined to the transaction unless the EntityManager join transaction method is invoked. An application managed persistent context associated with the resource local entity manager is always automatically joined to any resource local transaction that is begun for EntityManager. Now we are considering transaction commit. The managed entities of a transaction is called persistent context before become detached when the transaction commits. The managed entities of an extended persistent context remain managed. Now we are considering transaction rollback. For both transaction scope persistent context and for extended persistent context that are joined to the current transaction, transaction rollback causes all pre-existing managed instances and removed instances to become detached. The instances state will be state of the instances at the point at which the transaction knows rollback. Transaction rollback typically causes a persistent context to be in the consistent state at the point of rollback. In particular, the state of the version of attributes and generated state, for example, generated primary keys, may be inconsistent. Instances that were formerly managed by the persistent context, including new instances that were made persistent in the transaction, may therefore not be reusable in the same manner as other detached objects. For example, they may fail when passed to an merge operation. Because transaction is scoped persistent context lifetime is scoped to the transaction regardless of whether it is joined to the transaction. The container closes the persistent context upon transaction rollback. However, an extended persistent context that is not joined to the transaction is unaffected by transaction rollback. Now we are considering container managed transaction scope persistent context in container managed persistent context in EntityManager's persistent context. The persistent context type for the EntityManager is defaulted or defined as a persistent context type.transaction. Public static final context type transaction, persistent context type transaction in enum persistent context type in package jakarta.persistent in module jakarta.persistence. Transaction is called persistent context. An application can obtain container managed entity manager with the transaction scope persistence context by injecting or direct lookup in the JNDI namespace. The persistent context type for the entity manager is defaulted or defined as persistent context type dot transaction. New persistent context begins with, when the container managed entity manager is invoked in the scope of an active JTA transaction, and no current persistent context is already associated with the JTA transaction. Persistent context is created and then associated with the JTA transaction. This association of the persistent context with the JTA transaction is independent of the synchronization type of the persistent context, whether the persistent context has been joined to the transaction. Persistent context ends when the associated JTA transaction commit or rollback, and entities that were managed by the entity manager become detached. If the entity manager is invoked outside the scope of a transaction, any entities loaded from the database will immediately become detached at the end of the method call. Here's now we are considering an examples. Here you can see the container managed transaction scope persistent context. Now we are considering application managed persistent context with the resource transaction. Here the application managed for persistent context example here. Here usage in an ordinary Java class. Here transaction begin. Commit. Now we are considering transaction type attributes in persistent.xml file in persistent unit packaging in entity packaging. Transaction type attribute is used to specify whether the entity managers provided by the EntityManagerFactory for the persistent unit must be JTA entity or resource local entity managers. The value of this element is JTA or resource underscore local. The transaction type JTA assumes that the JTA data source will be provided either as specified by the JTA data source element or provided by the container. In general, the Jakarta EE environments, the transaction type of resource underscore local assumes that the non-JTA database data source will be provided. In Jakarta E environment, this element is not if this element is not specified, the default is JTA. In Java SE environment, if this element is not specified, the default is resource underscore local. Example, we can consider this one, illegal state exception. If isActive method is true in method void begin in interface entity transaction. Now we are focusing on query. The jakarta.persistence.query interface is implemented by each vendor to find persistent objects that meet certain criteria. Jakarta persistence query language, criteria API, and native SQL select queries are executed using the get result list and get single result methods. Update and delete operations, update and delete queries are executed using the execute update method. Here you can see the criteria query encapsulate the clauses of traditional query. Criteria query is a tree of query expression nodes that are used to specify query clauses from where order by in a traditional string-based query language. This figure shows the clauses related to a query. The core expressions are generically type. A few typical expressions are root t, which are equivalent to from clause, predicate, which equivalents to a Boolean value of true or false in fact it is declared as the interface predicate extend expression Boolean. Path which denotes the persistent attribute navigated from root question mark root question expression. Root t is a special path t with no parent. Criteria criteria builder is factory for criteria query and core expressions of all sorts. Criteria query transfers to an executable query which its type information preserved so that the element of selected list can be accessed without any runtime casting. Here the interface abstract query type parameter t in package jakarta.persistence.criteria in module jakarta.persistence. The t is the type of the result, and the abstract query interface defines functionality that is common to both top level queries and subqueries. It is not intended to be used directly in query construction. The interface criteria query the criteria query interface defines functionality that is specific to top level queries. Interface subquery t, the subquery interface defines the functionality that is specific to subqueries. A subquery is an expression as its selection item. Interface selection x X is the type parameter, X is the here the T, the type of the selection item. The selection interface selection, the selection interface defines an item that is to be returned in a query result. Interface predicate, the type of a simple or compound predicate, a conjunction of disjunctions of restrictions. A simple predicate is considered to be a conjunction with a single conjunct. Interface root, here the type parameter, here we put X, the entity type referenced by the root. The interface root, the root type in the from the root type in the from clause. Query roots always reference entities. Interface join, here the type X, the source type of the join, and here the target type of the join. A join to an entity embeddable or basic type. Interface interface expression, T, the type of the expression. Type for query expressions. Interface order, an object that defines an ordering of a query results. Here the you can see the abstract query. Here the join is connected to root, and selection, predicate, root, expression, predicate, and predicate are connected to abstract query, and query criteria query and subquery are connected to abstract query here, and the order is connected to criteria query, and query build interacts with criteria query. Here the here 0 or 0 to or 1 selection is connected to abstract query via select, and here predicate 0 to 1 predicates is connected to abstract query via where, and 0 to many root roots are connected to abstract query via from, and 0 to many expression is connected to abstract query via group by, and 0 to 1 predicate is connected to having abstract query via having, and 0 to many order are connected to orders is connected to order abstract criteria query via order by. Here 0 to many join is connected to from. Here you can see generic type arguments T criteria query T select the instance of type X in this graph here. Here you can see criteria API interfaces. The heart of the criteria API is the criteria builder interface obtained from the EntityManager interface by calling getCriteriaBuilder method. The criteria builder interface is a large and serves several purposes within the criteria API. It is a factory with which we create query definition itself, an instance of criteria query interface, as well as many various components of the query definition such as conditional expressions. Criteria builder interface provides provides three methods for creating a new select query definition. Depending on the desired result type of the query. The first and most common method is criteria query class type parameter T method, passing in the class corresponding to the result of the query. The second method is a create query without any parameters and correspond to the query with the result type object. The third method is create tuple query. Is used to projection of or report queries where select clause of the query contains more than one expression and you wish to work with the result in a more strongly typed manner. It is really just a convention method that is equivalent to invoking create query tuple.class. Note that the tuple is an instance that contains an assortment of object or data and applies typing to the aggregate part. It can be used whenever multiple items are returned and you want to combine them into a single type object. It is worth noting that despite the name, criteria query instance is not a query object that may be invoked to get results from the database. It is a query definition that may be passed to the create query method and EntityManager interface in place of jakarta.persistence QL string. The only real difference between criteria query definition and jakarta.persistence QL string is the method of building the query definition, programming API versus text, and those criteria queries are basically typed, so result type does not have to be specific when invoking create query on EntityManager in order to obtain typed query instance. You may also find it useful to think a fully defined criteria query instance as being similar to internal representation of jakarta.persistence QL query that a persistent provider might use after passing the jakarta.persistence QL string. Criteria API is composed of a number of interfaces that work together to model structure of jakarta.persistence query. Criteria builder interface criteria builder used to construct criteria queries, compound selections, expressions, predicates, orderings. Interface tuple element x type parameter x in package jakarta.persistence in module jakarta.persistence. The tuple element interface defines an element that is returned in a query result type. Interface selection here T in package jakarta.persistence.criteria in module jakarta.persistence. Selection interface defines an item that is to be returned in a query result. Interface compound selection. The compound selection interface defines the compound selection item, tuple, array, or result of construction. Here exists the type of the selection item. Interface expression, type for core expressions. Here the type parameter t is the type of the expression. Interface parameter expression t, type of criteria query parameter expressions. Interface parameter t, type for query parameter objects. Interface predicate, the type of a simple or compound predicate, a conjunction or disjunction of restriction. Simple predicate is considered to be a conjunction with a single conjunct. Interface subquery t, the subquery interface defines functionality that is specific to subqueries. A subquery has an expression as its selection item. Here the t is the type of the selection item. Interface criteria query. The criteria query interface defines functionality that is specific to top level queries. T is the type of the defined result. Interface abstract query. The abstract query interface defines functionality that is common to both top level queries and subqueries, that is not intended to be used directly in query construction. T is the type of the result. Interface common abstract criteria. The common abstract criteria interface defines functionality that is common to both top level criteria queries and subqueries, as well as top level criteria queries, subqueries, as well as update and delete criteria operations. It is not intended to be used directly in query construction. Interface criteria update t. The criteria update interface defines functionality for performing bulk update operations using the criteria API. Interface criteria delete t. The criteria delete interface defines functionality for performing bulk delete operations using using the criteria API. Interface path represents a simple or compound attribute path from a bound type or collection. And is a primitive expression. The T is the type referenced by the path. Interface fetch represent the joint fetch association for or attribute. Here T is the source type of the fetch and X is the target type of the fetch. Interface fetch parent represent an element of the from clause which may function as the parent of fetches. Interface from the represent a bound type, usually an entity that appears in a from clause but may also be an embeddable belonging to an entity in the from clause. Interface root, the root type in the from clause. Query roots always reference entities. Here the X, say the T is the entity type referenced by the root. Interface join, TU here, join to an entity, embeddable or basic type. So here the source type of the joint and here the target type of the joint, the type parameters. Interface plural join. The plural join interface defines functionality that is common to joins to all collection types. It is not intended to be used directly in a query construction. Here the type parameters: source type, collection type, element type of the collection. Interface collection join. Here TU, the collection joint interface is a type of the result of joining to a collection or an association or element collection that has been specified as java.util.collection. Here the source type parameters, the source type of the join and element type of the target collection. Interface set join, type parameter here T are the source type of the join and the element type of the target set. The set join interface is a type of the result of joining to a collection or association or element collection that has been specified as java.util.set. List join, the list join interface is the type of the result set of joining to a collection or an association or element collection that has been specified as java.util.list. Map join, the map join interface is the type of the result of joining to a collection or an association or element collection that has been specified as a java.util.map. Interface order, an object that defines an ordering over the query results. So here you can see criteria builder. Tuple element has sub interface selection. Selection has sub interfaces compound selection expressions, and expression has sub interface parameter expression, and parameter expression has a super interface parameter. selection has a sub-interface compound selection and expression also. See, expression has sub-interfaces predicate, path, subquery, and criteria query here. Criteria query has a super interface abstract query, and abstract query has a super interface command abstract criteria. It has sub interfaces criteria update and criteria delete here. The path has sub interfaces fetch tu and from tu and from tu. Fetch tu has super interface fetch parent tu here, and here you can see order. And from has sub interfaces root and join, and here the root has sub interfaces pura join tuv. Pura join has sub interfaces collection join tu, set join tu, and list join tu, and map join t. Now we are considering query cache. Here you can see query cache. The Jakarta persistent doesn't currently define a mechanism for caching of queries. Data nucleus provide 3 levels of caching. Here, query caching with the data nucleus. Data nucleus provide 3 levels of caching. Generic compilation. When a query is compiled, it is initially compiled generically into expression trees. This generic compilation is independent of the data store in use, so it can be used for other data sources. This can be cached. Data store compilation. After query is compiled into expression trees above here, it is then converted into a native language of the data store in use. For example, RDBMS is converted to SQL. This can be cached. Results when the queries run and return object of the candidate type, you can cache the identities of the result objects. Here you can see the query, user query, JDOQL, JPQL, the select from my class where if ID 1, if FLD1 equal colon param. User query is connected to generic compilation, expression trees for each query component, data store independent. Generic compilation is connected to data store compilation, data store native query, for example SQL, etc. Select asterisk from my TBL where FLD COL equal question mark. An example we can consider interface query. Interface used to control query execution. This is in module jakarta.persistence and package jakarta.persistence. As an example too, we can consider this code segment here with EntityManager. You can see here the create query method, and here the Jakarta persistent query string. The create query method here creates an instance of query for executing a Jakarta persistent query language statement. Here you can see the set parameter method in query, bind an argument value to a named parameter. Here bind an argument value to a name parameter here. This is the parameter name and this is the parameter value. Here you can see a set max result method in query interface. Set the maximum number of results to retrieve, here 10. Here you can see a get result list in query interface. Execute a select query and return the query results as an untyped list. For type query instances, the query result type is determined in the case of criteria queries by the type of query specified when the criteria query is created. And in the case of Jakarta persistence query language queries, the type of the result is determined by the result class argument to the create query or create named query method, and select list of query must contain only a single item which must be assignable to the specified type. Here you can see type query interface used to control the execution of typed queries. Here you can see EntityManager's the create query method in EntityManager here with the parameter. This is the criteria query parameter, a criteria query object here, and this create query method creates an instance of typed query for executing a criteria query. Here you can see a get single result method of type query. Execute a select query that returns a single result. And the type query is in module jakarta.persistence and package jakarta.persistence. As an example 4, we can consider this one. This example illustrates the case where a native SQL query is created dynamically using the create native query method, and the entity class that specify the type of the result is passed as an argument. When executed, this query will return a collection of all order entities for items name widget. Here you can see the method create native query in EntityManager. Create an instance of query for executing a native SQL query. Here you can see a native SQL query string, and this is the class of the resulting instances. As an example 5, we can consider this. Here you can see the method create stored procedure query method in EntityManager here. Create an instance of stored procedure query for executing stored procedure in the database. Here you can see the procedure name, and the interface stored procedure query interface used to control procedure query execution, control stored procedure query execution. And design jakarta.persistent module and jakarta.persistent package. As an now we are considering query interface in query APIs. Interface query in package jakarta.persistent in module jakarta.persistence. Interface used to control query execution. Typed query interface type query type parameter x in package jakarta.persistence in module jakarta.persistence. Interface used to control the execution of typed queries. Tuple interface tuple in package jakarta.persistence in module jakarta.persistence. Interface for extracting the elements of a query result tuple. Tuple element interface tuple element x in package jakarta.persistence in module jakarta.persistence. The tuple element interface defines an element that is returned in query result tuple. Parameter interface parameter type parameter t. The package jakarta.persistence in module jakarta.persistence type for query parameter objects. Stored procedure query interface stored procedure query in package jakarta.persistence in module jakarta.persistence. Interface used to control stored procedure query execution. Here you can see query execution. You can see the example. The interface query in package jakarta.persistence in module jakarta.persistence. You can see the method get result set, the list get result set. Execute the select query and return the query result as an untyped list. With query execution, the Jakarta persistent query language criteria API native select queries are executed using get result list and get single result method. Update and delete operations, update on delete queries are executed using execute update method. For typed query instances, the query result type is determined in the case of criteria queries by the type of the query specified when the criteria query object is created. In the case of Jakarta persistent query language queries, the type of the result is determined by the result class argument in the create query or create named query method, and select the list of the query must contain only single item which must be assignable to a specific type. The query instances, the element of the query result whose select list consists of more than one select expressions of the type object array. if the select list consists of only one select expression, the elements of the query result are of the type object. When the native SQL queries are used, the SQL result set mapping determine how many items, entities, scalar values, etc. are returned. If multiple items are returned, the elements of the query result are of type object array. If a single item is returned as the result of the SQL, the result set mapping or the result set class is specified, the element of the query result are of the object type. Stored procedures queries can be executed using get result set. Single result and execute methods. Stored procedures that perform only updates or deletes can be executed using execute update method. An illegal argument exception is thrown if the parameter instance is specified and that does not correspond to the parameter of the query. If parameter name is specified that does not match the corresponding that does not correspond to the parameter that does not correspond to the named parameter of the query of the positional. If the positional value is specified that does not correspond to the positional parameter of the query, or if the type of the parameter is not valid for the query, this exception may be thrown when the parameter is bound or the execution of the query may fail. The effect of applying set max result or set first result to a query involving fetch join server collections is undefined. The use of set max result and set first result is not supported for stored procedure queries. Query and type query methods other than execute update method are not required to be invoked within the transaction context unless the lock mode other than lock mode type none has been specified for the query. In particular, the get result set and get single result methods are not required to be invoked within the transaction context unless such a lock mode has been specified for the query. If an entity manager with the transaction scope persistent context is in use, the resulting entities will be detached. If the entity manager with the extended persistent context is used, they will be managed. Whether the stored procedure query should be invoked in a transaction context should be determined by the transactional semantics or requirement of the stored procedure implementation and the database in use. In particular, problems may occur if the stored procedure initiates a transaction and transaction is already in effect. The state of the entities returned by the stored procedure query invocation is determined as runtime exception other than no result exception, non-unique result exception, query time out exception, and lock timeout exception thrown by the method of the query. Type query and stored procedure interfaces other than those methods described below cause the current transaction to be marked for rollback if the persistent context is joined to the transaction. On the database platform on which the query timeout causes transaction rollback, the persistent provider must throw the persistent exception instead of query timeout exception. Runtime exceptions are thrown by the following methods of the query: type query and stored procedure query interfaces do not cause current transaction to be marked for rollback. Get parameter, set parameter, get parameter, get parameter, get parameters, get parameter value, get output parameter value, and set get lock mode. The runtime exception thrown by the method of the tuple and tuple element and parameter interfaces do not cause the current transaction to be marked for rollback. Now we are considering queries and flush mode. If the persistence context has been joined to the current transaction, the persistent provider must not flush the database regardless of the flush mode setting. Enum flush mode type in package jakarta.persistence in module jakarta.persistence flush mode setting. The flush mode setting affects the result of the query as follows. When the queries are executed within transaction, if the flush mode type auto dot auto is set on the query, the type query or stored procedure query object, or if the flush mode settings for the persistent context is auto, the default, and the flush mode get mode setting has not been specified for the query object, the persistent provider is responsible for ensuring that all updates to the state of all entities in the persistent context which could potentially affect the result of the query are visible or to the processing of the query. The persistent provider implementation may achieve this by flushing those entities to the database or by other means. If the flush mode type.commit is set, the effect of updates made to the entities in the persistent context upon queries are unspecified. If the persistence context has not been joined to the current transaction, the persistent provider must not flush the database regardless of the flush mode setting. If there is no transaction active, the persistent provider must not flush to the database. The flushing occur at the transaction commit. The provider may flush at other times but is not required to. The default flushing to occur at query execution. Now we are considering queries and lock mode. The set lock mode method of the query or type query interface or the lock mode element of the named query annotation may be used to lock the result of the query. The query set lock mode type lock mode in interface query in package jakarta.persistence in module jakarta.persistence. Set the lock mode type to be used for query execution. The set lock mode method for query or type query interface or the lock mode element of the named query annotation may be used to lock the result of a query. A lock is obtained for each entity specified in the query result, including entities passed to the constructors in the query select was. If the lock mode type is pessimistic read, pessimistic write, pessimistic force increment, and the query returns scalar data, for example, the values of the entity field or properties including scalar data passed to the constructors in the query select was, the underlying database rows will be locked, but the version columns of any entities corresponding to the scalar data will not be updated unless the entities themselves are also otherwise retrieved and updated. If the lock mode is optimistic or optimistic force increment, and the query returns scalar data, any entities returned by the query will be locked, but not locking. The locking will occur for the scalar data that does not correspond to the state of the entity instance in the query result. If the lock mode other than none is specified for the query must be executed within the transaction, and the persistent context must be joined to the transaction, or the transaction required exception will be thrown. Locking is supported by Jakarta persistence query language queries and criteria queries only. If the set lock mode and get lock mode method is invoked on a query that is not a Jakarta persistent query language, select query or criteria query, the illegal state exception may be thrown or the query execution will fail. Now we are considering query hints. The following hint is defined by this here by for use in query configuration. This hint may be used with the query type query or stored procedure query, set hint method, or named query, named native query, or named stored procedure query annotations. It may also be passed as a property to the persistent.create EntityManagerFactory method and used in the properties element in the persistence.xml. When used in the create EntityManagerFactory method, the persistent.xml and file and the annotations, the timeout hint serves as a default value which can be selectively overwritten by the set hint method. Portable applications should not rely on this hint. Depending on the persistent provider and database in use, the hint may or may not be observed. Vendors are pointed to support the use of traditional vendor-specific hints. Specific hints must not be used. The jakarta.persistence namespace. Vendor-specific hint must be ignored if they are not understood. Now we are considering parameter objects. Parameter objects can be used for criteria queries and Jakarta persistence query, Jakarta persistence query language queries. Interface parameter type parameter T, in package jakarta.persistence, in module jakarta.persistence. Type for query parameter objects. Parameter objects can be used for criteria queries and for Jakarta persistence query language queries. Implementation may support the use of parameter object for native queries. However, support for parameter object for the native queries is not required by the specification. The use of the parameter objects for native queries will not be portable. Mixing of parameter object with the named and positional parameters is invalid. A portable application should not attempt to reuse the parameter object obtained from a query or type query instance in the context of a different query or type query instance. Now we are considering named parameter. A named parameter of Jakarta persistence query language query is an identifier that is prefixed by the colon symbol. Named parameters can be used for Jakarta persistence query language queries, for criteria queries, although use of parameter objects to be preferred, and for stored procedure queries that support named parameters. Named parameters are case sensitive. Mixing of named and positional parameters is invalid. Named parameter for Jakarta persistent query language query is an identifier that is prefixed by the name colon symbol. The parameter names passed to the set parameter methods of the query and type query interfaces do not include this colon prefix. Now we are considering positional parameters. When binding the queries of the positional parameters, the numbering start as 1. Only positional parameter binding and positional access to result items may be portably used for native queries, except for stored procedure queries for which the names parameters have been defined. When binding the values of positional parameters, the numbering starts with as 1, and it is assumed that for native queries the parameter themselves use the SQL syntax, for example question mark rather than question mark 1. The use of positional parameters is not supported for criteria queries. Now we are considering named queries. Following is an example of the definition of a named query defined in metadata. The annotation typed named query in package jakarta.persistence in module jakarta.persistence specified a static named query in the Jakarta persistence query language. Query names are scoped to the persistent unit. The named query annotation can be applied to an entity or mapped superclass. Named queries are static queries expressed in metadata or query registers by means of the EntityManagerFactory. Add named query method. This is entity manager, so in the EntityManagerFactory add named query method. Named queries can be defined in the Jakarta persistence query language or in SQL. Query names are scoped to the persistent unit. The following is an example of definition of a named query defined in metadata. The following is an example of the use of a named query. Now we are considering polymorphic queries. For example, the following query returns the average salary of all employees, including subtypes of employee, such as manager and exempt. By default, all queries are polymorphic. That is the from clause of a query designate not only instances of the specific entity classes to which the explicitly refers, but subclasses as well. The instances returned by the query include instances of subclasses that satisfy the query conditions. For example, the following query returns the average salary of all employees, including subtypes of employee such as manager and exempt. So here the employee has subtypes of subtypes such as manager and exempt. Now we are considering returning manage entities from native queries. The following example illustrates the case where the native SQL query is created dynamically using a create native query method, and entity class that specifies the type of the result is passed as an argument. The method query create native query string SQL string and class result class create an instance of a query for executing native SQL query. The persistent provider is responsible for performing mapping between the values returned by the SQL query and the entity attributes in the accordance with the object relational mapping metadata for the entity or entities. In particular, names of the columns of the SQL result are used to map to the entity attributes as defined by its metadata. This mapping includes the mapping of the attributes of any embeddable classes that are part of the non-collection values entity state, and attributes correspond to the foreign keys contained as part of the entity state. When an entity is to be returned from a native query, the SQL element should select all the columns that are mapped to the entity object. This should include foreign key columns to related entities. The result obtained when insufficient data is available are undefined. In the simplest case, that is when the result of a query are limited to entities in a single entity class, the mapping information can be derived from the columns of the SQL result and the object relational mapping metadata. It is sufficient to specify only the expected class of the entity result. The following example illustrates the case where the native SQL query is created dynamically using create native query method, and the entity class that is specified the result of the type of the result is passed as an argument. When executed, this query will return a collection of order entities for item named widget. The SQL result set mapping metadata annotation, which is designed to handle more complex cases, can be used as an alternative here. For a query shown the query shown here, the SQL result set mapping metadata for the query result type might be specified as follows here. The same result is produced by the native query here, can then obtain by the following. When multiple entities are returned by the SQL query, or when the column names of the SQL query result do not correspond to those of the object relational mapping metadata, the SQL result set mapping metadata definition must be provided to specify entity mapping. Now we are considering named stored procedure queries in stored procedures. Unlike in the case of named query, native query, the named stored procedure query annotation names the stored procedure that exists in the database rather than providing a stored procedure definition. Annotation type named stored procedure query in package jakarta.persistence in module jakarta.persistence specified the names of the stored procedure, its parameters, and its result type. Unlike in the case of named native query, the named stored procedure query annotation names the stored procedure that exists in the database rather than providing stored procedure definition. The named stored procedure query annotation specifies the types of all parameters to the stored procedure, their corresponding parameter modes, in out, ref cursor, and how result set, if any, are to be mapped. The name that is assigned to the stored procedure in the named stored procedure query annotation is passed as an argument to the native create named stored procedure query method to create an executable stored procedure query object. The stored procedure may return more than one result set. As with the native queries, the mapping of the result set can be specified either in terms of result classes or as a result set mapping annotation element. If there are multiple result sets, it is assumed that they will be mapped using same mechanism. For example, all via a set of results class mapping or all via a set of result set mapping. The order of specification of these mappings must be the same as the order in which result set will be returned by the stored procedure invocation. If the stored procedure returns one or more result set and no result classes or result set mapping element has been specified, the result set will be returned as a list of type object array. The combining of different strategies for the mapping of the stored procedure result set is undefined. Stored procedure parameter metadata needs to be provided for all parameters. Parameters must be specified in the order in which they occur in the parameter list in the stored procedure. If the parameter names are used, the parameter names is used to bind the parameter value and extract the output value if the parameter is in-out or out parameters. If the parameter names are not specified, it is assumed that the positional parameters are used. Mixing of named and positional parameters is invalid. Now we are considering an overview in query language. The Jakarta persistent query language is a query specification language for string-based dynamic queries and static queries expressed through metadata. It is used to define queries over persistent entities defined by designed by the specification and their persistent state and relationships. Jakarta persistent query language can be compiled to a target language such as SQL of a database or other persistent store. This allows the execution of queries to be shifted to a native language facilities provided by the database instead of requiring queries to be executed on runtime representation of the entity state. As a result, query method can be optimizable as well as portable. The query language uses the abstract persistent schema of entities, including their embedded object and relationships, for its data model, and it defines operators and expressions based on this data model. It uses SQL-like syntax to select object or values based on the abstract schema types and relationships. It is possible to pass and validate queries before entities are displayed. The term abstract persistent schema refers to the persistent schema abstraction, persistent entities, their state, and their relationships over which Jakarta persistent queries operate. Queries over this persistent schema abstraction are translated into queries that are executed over the database schema to which entities are mapped. Queries may be defined in metadata annotations or SQL descriptor. The abstract schema types of a set of entities can be used in query if the entities are defined in the same persistent unit as the query. Path expressions path expressions allow for navigation or relationships defined in the persistent unit. A persistent unit defines the set of classes that are related or grouped by the application to which must be co-located in their mapping to a single database. Now we are considering select statements in statement types. In BNF syntax, a select statement is defined as here. A select statement is a string which consists of following clauses. Select clause which determines the type of the object or values to be selected. From clause clause which provides a declaration to designate the domain to which the expression specified in the other clauses of the query apply. The optimal where clause which may be used to restrict the result that were returned by the query. Optional group by clause which allows the query results to be aggregated in terms of groups. Optional having clause which allows filtering of aggregated groups. Optional order by clause which may be used to order the results that are returned by the query. In BNF syntax, select statement is defined as here. The select statement must always have select and from clause. The square brackets indicates that the other clauses are optional. Now we are considering abstract schema types and query domains. An example here. This example assumes that the application developer provides several entity classes representing orders, products, and line items. And an embeddable address class representing shipping address and billing addresses. The abstract schema types for the entities are order, product, and line item respectively. There is one-to-many relationship between order and line item, and entity line item is related to product in many-to-one relationship. The classes are logically in the same persistent unit as shown in here. Query to select orders can be defined by navigating over the associated fields, and the state fields are defined by order and line item. A query to find all orders with pending line items might be written as follows here. Here the abstract persistent schema for several entities with defined in the same persistent unit. This query navigate over the association field line items of the abstract schema, type order to find the line items, and uses the field shipped of line item to select those orders that have at least one line item that has not yet been shipped. Note that this query does not select orders that have no line items. Although reserved identifiers such as distinct, from, as, join, where, and false appear in uppercase. In this example, the reserved identifiers are case insensitive. Select clause of this example designate the return type of this query to be a type of order. Because the same persistent unit defines the abstract persistent schema of the related entities, the developer can also specify the query over orders utilizes the abstract schema type of products, and hence the state fields and associated fields of both abstract schema types of order and product. For example, if the abstract schema type product has a state field named product type, a query over orders can be specified using the state fields. Such a query might be able to find all orders of products with the product type office supplies. The query for this might be as follows. Because order is related to product, by means of relationship between order and line item, and between line item and product, navigation using associated field line items, and product navigation using associated fields line items and products is used to express the query. This query is specified by using the entity name order, which designate the abstract schema type over which the query ranges. The basis for the navigation is provided by the associated field line items and product of the abstract schema type order and line item respectively. Now we are considering from clause and navigational declarations, identification variables in from clause and navigational declarations. For example, consider the previous query. An identification variable is a valid identifier declared in the from clause of a query. All identification variables must be declared in the from clause. Identification variables cannot be declared in other clauses. An identification variable must not be reserved identifier or have the same name as any entity in the same persistent unit. Identification variables are case sensitive. An identification variable evaluates to a value of type of the expression used in the declaration variable. For example, consider the previous query here. In the from clause declaration line items L, the identification variable L evaluates to any line item value directly reachable from the order. The associated field line items in a collection of instances of abstract schema type line item, and the identification field L refers to an element of this collection. The type of the L is the abstract schema type line item. The identification variable can range over any entity, embeddable or basic abstraction schema type. An identification variable designate an instance of an abstract schema type or an element of a collection of abstract schema types, abstract schema type instances. Note that for identification variable referring to an instance of an association or collection represented by java.util.map, the identification variable is of the abstract schema type of the map value. An identification variable always designate the reference to a single value. It is declared in a one of three ways: a range of variable declaration in the join clause, or in a collection member declaration. Range of variables. In a range variable, in a join clause, or in a collection member declaration. And education variable declarations are evaluated from left to right in the from clause. And the identification variable declaration can use the result of the preceding identification variable declaration of the query string. All identification variables used in select, where, order by, group by, having clause of the select or delete statement must be declared in the from clause. The identification variable used in where clause of an update statement must be declared in the update clause. Identification variables are extremely qualified in these clauses. Essential identification variables are essentially quantified in this clause in clause variables in these clauses. This means an identification variable represents a member of a collection or instance of an entity abstract schema type. An identification variable never designate a collection in its entirely. An identification variable is scoped to a query or subquery in which it is identified and is visible to any subqueries within that query scope that do not define the identification variable of the same name. Now we are considering where clause. A where clause is defined as follows. A where clause is a query consists of a conditional expression used to select object or values that satisfy the expression. The where clause restricts the result of the select statement or scope of an update or delete operation. A where clause is defined as follows. The group by construct enabled aggregation of values according to the properties of an entity class. Having construct enable the condition to be specified that further restrict the query result as a restriction upon groups. Syntax of the having clause is as follows. The group by and having construct this is the syntax as follows here. Here we are considering the literals in conditional expressions. For example, here a literal string literal is enclosed in a single quotes. For example, string literal that includes a single quote is represented by two single quotes. That includes a single quote is represented by two single quotes. For example, literal quotes, literal quote, s quote. Single literals are in queries like string literals and use Unicode character encoding. The use of Java escape notation is not supported in the query literals. String literals. Extract numerical literals support the use of Java integer literal syntax as well as SQL extract numeric literal syntax. Appropriate suffixes can be used to indicate the specific type of numeric literal in accordance with the Java language specification. Support for the use of hexadecimal and octal numeric literals is not required by the specification. Enum literals support the use of Java enum literal syntax. Fully qualified enum class name must be specified. The JDBC escape syntax may be used for specification of date, time and timestamp literals, for example. The portability of this syntax for date, time and timestamp literal is dependent upon the JDBC driver in use. Persistent providers are not required to translate this from this syntax into native syntax of the database or driver. Boolean literals are true and false. Entity type literals are specified by the entity names, for example, customer. Although resolved literals appeared in uppercase, they are case insensitive. Now we are considering group by and having examples are here. Some examples are here. The group by construct enables the aggregation of results values according to a set of properties. The having clause having construct enable condition to be specified further restrict the query result. In such conditions are restrictions upon the groups. The syntax of the group by and having clauses is as follows. If the query contains both where clause and group by clause, the effect is that of the first applying the where clause, then forming the group and filtering them according to having clause. Having clause causes the groups to be retained and retained that satisfy the condition of having clause. Requirement of for the select clause when group by is used follow those of SQL, namely any item that appears in the select clause other than as an aggregate function or as an argument to an aggregate function must also appear in the group by clause. In forming groups, null values are treated as the same as grouping purposes. As the same for grouping purposes. Grouping by an entity is permitted. In this case, the entity must contain no serialized state field or lob values state field that are eagerly fetched. Grouping by an entity that contains serialized state fields or lob values state fields is not portable, since the implementation is permitted to eagerly fetch fields or properties that have been specified as lazy. Grouping by an embeddables is not supported. Having clause is used to filter over groups and contain aggregate functions or attributes including the groups and or functions or other query language operations or attributes that are used for grouping. It is not required that an aggregate function used in having clause also be in the select select clause. If there is no group by clause and the having clause is used, the result is treated as a single group, and the select list can only consist of aggregate functions. The use of having clause in the absence of group by is not required to be supported by an implementation of this in this Java persistent specification. Jakarta persistent specification. Portable application should only rely on having without use of group by. Portable application should not rely on having without use of group by. The examples are here. Some examples you can see here. Now we are considering select clause. For example, here, and select clause denotes the query result. More than one may be returned from the select clause as a query. Select clause can contain one or more of the following elements: identification variables, that ranges of abstract schema type, single values path expressions, and scalar expression, and aggregate expression, a constructor expression. Select clause has following syntax here. For example, here in the following example, the video inventory is a map from the entity movie to the number of copies in the stock. And note that select clause must be specified to return only a single value expressions. The query below the query is therefore the query below this one is not valid. The distinct keyword is used to specify that the duplicate values must be eliminated from the query result. The distinct is if the distinct is not specified, duplicate values are not eliminated. The result of the distinct or embeddable object or map entity result is undefined. Standard identification variables in the select clause may optionally be qualified by the object operator. The select clause must not use the object operator to qualify path expressions. The result variable may be used to name the select item in the query result. Example here. This is not valid. Now we are considering order by clause. For example, the 4 queries below here are legal. The order by clause allows the object or values that are returned by the query to be ordered. The syntax of the order by clause is here. An order by item must be one of the following. A field path expression that evaluate to an ordinary state field of an entity or embeddable class abstract schema type designated in the select clause by one of the following: a general identification variable, a single valued object path expression. A state state field path expression that evaluate to the same state field of the same entity or embeddable abstract schema type as an state field path expression in the select clause. A general identification variable that evaluates to a same map field of the same entity or embeddable abstract schema type as the general identification variable in the select clause. A result variable that refers to an orderable item in the select clause for which the same result variable has been specified. This may be the result of the aggregate expression, scalar expression, or state field path expression in the select clause. For example, 4 queries here are legal. The following queries are not here. These are not legal because the order by item is not reflected in the clause of the query. If the more than one order by item is specified, the left to right sequence of the order by elements determines the precedence, whereby the leftmost order by item has the highest precedence. The keyword ASC specify the ascending order to be used for the associated order by item. The keyword DESC specify the descending order to be used. Ascending ordering is the default. SQL rules for ordering of null values apply. That is, all null values must appear before all non-null values in the ordering, or all null values must appear after all null values in the ordering, but it is not specified which. The ordering of the query result is perceived in the result of the query execution method. Order by clause is used. So these two queries are not, these two are not legal. Now we are considering bulk update and delete operations. These are the examples. Bulk update and delete operations apply to entities of a single entity class together with its subclasses, if any. Only one entity abstract schema type may be specified in the from or update clause. Syntax of these operations is as follows here. Syntax of the where clause, we can see here. The delete operation only applies to entities of specified class and its subclasses. It does not cascade to related entities. The new value specified for an update operation must be compatible in the type with the field to which it is assigned. Bulk update maps directly to database or update operation, bypassing optimistic locking checks. Portable applications must manually update the value of the version column if desired, and or manually validate the value of the version column. The persistence context is not synchronized with the result of a bulk update or delete. Caution should be used when executing bulk update or delete operations, because they may result in inconsistencies between the database and entities in the active persistent context. In general, bulk update and delete operations should only be performed within a transaction in a new persistent context or before fetching and accessing entities. Those states might be affected by such operations. Examples are here. Now we are considering null values. When the target of the reference does not exist in the database, its value is regarded as null. The SQL null semantics define the evaluation of conditional expressions containing null values. The following is a brief description of these semantics. Comparison of arithmetic operation with null value always yield an unknown value. Two null values are not considered to be equal. Comparison yields an unknown value. Comparison of arithmetic operation with unknown values always yield an unknown value. The is null or is not null operators convert null state field or single valued value object value into respectful true or false value. Boolean operators use three valued logic defined in these three tables. The Jakarta persistent query language defined the empty string quotation as a string with 0 length, which is not equal to a null value. However, null values and empty strings may not always be distinguished when the queries are mapped to some databases. Application developers should therefore not rely on the semantics of the query comparison involving empty string and null value. Here, true and true, true and false, false, and true and unknown is unknown. Likewise, as you can see here, it's a false and unknown is false here, unknown and unknown is unknown, true and unknown is true, false and unknown is unknown, and unknown, true or unknown is true, false and or unknown is unknown, and unknown or unknown is unknown. Not true, false, not false, true is, and not unknown, unknown. Now we are considering equality and comparison semantics. Only the values of like types are permitted to be compared. Only a type is like another type if they correspond to a same Java language type, or if one is a primitive Java language type and other is wrapped Java class type equivalent. For example, int and integer are like types in the sense. There is one exception to this rule. It is valid to compare numeric values for which the rules of numeric promotions apply. Conditional expressions attempting to compare unlike types values are disallowed except for the numeric case. Note that the arithmetic operations and comparison operations are permitted to be applied to state field and input parameters of the wrapped Java class equivalents to the primitive numeric data types. Two entities of the same abstract schema are equal if and only if they have same primary key values. Not equality or inequality comparisons or enums are required to be supported. Comparisons of instances of embeddable class or map entry types are not supported. Here you can see we are considering some examples, simple queries in examples. Here find all orders. Here find all orders that need to be shipped to California. Find all find all states which there are orders. Now we are considering BNF notation summary in BNF. Here the summary grouping, optional construct, 0 or more, 1 or more, and alternates. Now we are considering an overview in criteria API. Jakarta.persistence.criteria, the package Jakarta.persistence.criteria in module Jakarta.persistence, the Jakarta persistent criteria API. The Jakarta persistence criteria API, like the Jakarta persistent query language, is based on the abstract persistent schema of entities, the embedded objects, and their relationships as its data model. This abstract persistent schema is materialized in the form of metamodel object over which the criteria API operates. The semantics of the criteria queries are designed to reflect those of Jakarta persistent query language queries. The syntax of the criteria API is designed to allow the construction of an object-based query graph whose nodes correspond to the semantics query elements. Java language variables can be used to reference individual nodes in the criteria query object as it is constructed or modified. Such variables, when used to refer to the entities and embedded types that constitute the query domain play a role analogous that of the identification variables Jakarta persistent query language. These concepts are further described later. The metamodel on which criteria query is based is presented in the documentation. The static metamodel classes that can be used in the constructing strongly typed criteria queries are also described in the documentation. Now we are considering static metamodel classes in metamodel. This is an example. Assume the order entity below here. The annotation is static metamodel in package jakarta.persistent.metamodel in module jakarta.persistence. The static metamodel annotation specified that the class is a metamodel class that represent an entity mapped superclass or embeddable class designated by the value element. Assume mode entity below here. And the corresponding canonical metamodel class order is as follows. Now we are considering here criteria builder interface in criteria API interfaces. Interface criteria builder in package jakarta.persistent.criteria in module jakarta.persistence used to construct criteria queries, compound selections, expressions, predicate, orderings. Now we are considering criteria query API usage. The jakarta.persistent.criteria API interfaces are designed to both allow criteria queries to be constructed in a strongly typed manner using metamodel objects to provide type safety and to allow for string based use as an alternative. Persistent package jakarta.persistent.criteria in module jakarta.persistence, Jakarta persistent criteria API. Yeah. The metamodel objects are used to specify navigation through joins and through path expressions. Type-safe navigation is achieved by specification of the source and target types of the navigation. Strings may be used as an alternative to metamodel object. Thereby, joins and navigations are specified by the use of strings and that correspond to attribute names. Using either the approach based on metadata model or string based approach, queries can be constructed both statically and dynamically. Both approaches are equivalent to in terms of the range of queries that can be expressed in operational statements. Now we are considering criteria query routes in query routes in constructing criteria queries. When executed, this query cause all instances of the customer entity to be returned. The module interface criteria query in package jakarta.persistent.criteria in module jakarta.persistence. The criteria query interface defines the functionality that is specified to top level queries. Interface root type x type parameter x in package jakarta.persistent.criteria in module jakarta.persistence. A root type in the from clause. Query roots always reference entities. A criteria query is constructed through the creation and modification of a jakarta.persistence.criteria.criteria query object. The criteria builder interface is used to construct criteria query, criteria update, criteria delete object. Criteria build implementation is accessed through the get criteria builder method of the entity manager or entity manager factory interface. For example, here the criteria root object is criteria query object is object defines a query over one or more entity embeddable or basic abstract or abstract schema types. The root object of the query are entities from which the other types are reached by the navigation. A query root plays a role analog to that of the range variable in the Jakarta persistent query language and forms the basis for defining the domain of the query. A query root is created and added to the query by use of the from method of the abstract query interface from which the both criteria query and subquery interface inherit. The arrangement to from method is the entity class or entity type instance for the entity. The result of the from method is a root object. The root interface extends from interface which represent object that may occur in the from clause of the query. The criteria object may have more than one root. The addition of a query root that has the semantic effect of creating a Cartesian products between the entity type referenced by the added root and those of the other roots. The following core illustrates the definition of a query root. When executed, this query causes all instances of customer entity be returned. Now we are considering constructing strongly typed queries using Jakarta.persistence metamodel interfaces. For example, here interface interface metamodel provide an metamodel in package Jakarta.persistence.metamodel in module Jakarta.persistence provide access to the metamodel of a persistent entities in a persistent unit. Strongly typed queries can also be constructed either statically or dynamically in the absence of generated metamodel classes. The Jakarta.persistence metamodel interfaces are used to access the metamodel object that correspond to the managed classes. The following examples illustrate this approach. This metamodel interface is obtained from the entity manager or EntityManagerFactory for the persistent unit and then used to obtain corresponding metamodel object for the managed types referenced by the queries. Now we are considering the use of criteria API with strings to reference attributes. This example. The criteria API provides an option to specifying attribute references using joins and navigation by attribute names as argument to various join, fetch, and get methods. The resulting queries have the same semantics but do not provide same level of type safety. Example in this section illustrate this approach. This example this query is equivalent to the following Jakarta persistent query language query. It is not required that type parameters be used. However, their omission may result compiler warnings as with the below version of the same query. Now we are considering query modification. The criteria query object might then be modified to reflect different predicate conditions. For example, here the interface criteria query. The criteria query type parameter T where predicate restrictions. Modify the query to restrict the result according to the conjunction of the specified restriction predicates. Replaces the previously added restrictions if any. If no restrictions are specified, any previously added restrictions are simply removed. This method only overrides the return type of the corresponding abstract query method. The criteria query criteria update or criteria delete object may be modified either before or after query or type query object has been created, executed from it. For example, such modification may enter replacement of the where predicate or the select list. Modification may result in the same query object based being refused for several query instances. For example, the user might create and execute a query from the following criteria query object. Criteria query object might then be modified to reflect the different predicate condition. Note, however, that query element in this example predicate conditions are dependent on the criteria query, criteria update, or criteria delete instance, and are thus not portably reusable with different instances. Now we are considering query execution. A criteria query is executed by passing the criteria query, criteria update, or criteria delete object to the criteria create query method of the EntityManager interface to create an executable type query object, or in the case of criteria update and criteria delete, the query object, which can then be passed to one of the query execution methods of the type query or query interface. Interface type query type X in package jakarta.persistence in module jakarta.persistence interface used to control the execution of type queries. A criteria query is executed by passing a criteria query, criteria update, or criteria delete object to the criteria create query method of the EntityManager interface to create an executable type query object, or in the case of criteria update or criteria delete, a query object, which can then be passed to one of the execution method of the type query or query interface. A criteria query, criteria update, or criteria delete object may be further modified after executable query object has been created from it. The modification of the criteria query, criteria update, or criteria delete object does not have any impact on the already created executable query objects. If the modified criteria query, criteria update, or criteria delete object is passed to the criteria query method, passed to the create query method, the persistent provider must ensure that the new executable query object is created and returned that reflect the semantics of the change query definition. Criteria query, criteria update, criteria delete object must be serializable. The persistent vendor is required to support the subsequent deserialization of such an object into a separate JVM instance of that vendor's runtime, where both runtimes instances have access to any required vendor implementation class. Criteria query, criteria update, criteria delete objects are not required to be interoperable across vendors. Now we are considering entity fetch graph semantics in use of entity graphs to find and query operations in entity graphs in entity operations. When Jakarta persistence, this is an example. When jakarta.persistence fetch graph property is used to specify entity graph, attributes are specified by the attribute nodes of the entity graphs are treated fetch type.eager, and attributes are not specified as treated fetch type.lazy. The following rules apply depending on attribute types. The rules of these sections are applied recursively. Primary key or version attribute never needs to be specified in an attribute node of the fetch graph. This applies to the composed primary keys as well, including embedded ID primary keys. When an entity is fetched, this primary key and version attributes are always fetched. It is not incorrect, however, is to specify primary key attributes or version attributes. Attributes other than primary key and version attributes are assumed not to be fetched unless the attributes is specified. Following rules apply to the specification of attributes. If the attribute is an embeddable attribute, the attribute is specified in an attribute not, but a subgraph is not specified for the attribute, the default fetch graph for the embeddable is fetched. If a subgraph is specified for the attribute and attributes are embeddable, are fetched according to the specification in the corresponding subgraph. If the attribute is an element collection of the basic type, the attribute is specified in the attribute node. The element collection together with its basic elements is fetched. If the attribute is an element collection of embeddables, the attribute is specified in an attribute node, but the paragraph is not subgraph is not specified for the attribute. The element collection together with the default fetch graph is of its embeddable element is fetched. If the subgraph is specified for the attributes of the embeddable element are fetched according to the corresponding subgraph specification. If the attribute is 1-to-1 or many-to-one relationship, the attributes is specified in the attributes node, but the subgraph is not specified in the for the attributes, and the default fetch graph of the target entity is fetched. If the subgraph is specified for the attributes of the target entity is fetched according to the corresponding subgraph specification. If the attributes is one-to-many or many-to-many relationship, the attributes is specified in the attributes node, but subgraph is not specified. The collection is fetched and the default fetch graphs of the reference entities are fetched. If the subgraph is specified for the attributes, the entities are in the collection are fetched according to the corresponding subgraph specification. If the key of the map which has been specified in the attribute node is a basic type, it is fetched. If the key of the map which has been specified in an attributes node is an embeddable type, the default fetch graph is fetched for the embeddable. Otherwise, if the fetch of the map and entity and map key subgraph is not specified for the attributes node, the map key is fetched according to its default fetch graph. If the key subgraph is specified for the map key attribute, the map key attribute is fetched according to the map key subgraph specification. In this example, a number attributes would be eagerly fetched. Now we are considering named query annotation in annotations for queries. The named query and named queries annotations can be applied to an entity or mapped super class. The annotation type named query in package jakarta.persistence in module jakarta.persistence. It specifies static named query in the jakarta.persistence query language. Query names are scoped to the persistent unit. The named query annotation can be applied to any entity and to an entity or mapped superclass. Named query annotation is used to specify the named query in the Jakarta persistence query language. Name is the element used. Name element is used to refer to the query which when using the EntityManager methods that create the query object. Query element must specify the query string in Jakarta persistence query language. Lock mode element specifies a lock mode for the result returned by the query. If the lock mode other than none is specified, the query must be executed within the transaction and persistent context joined to the transaction. Hints element may be used to specify query properties, and hints properties defined by this in the Jakarta specification must be observed by using provider. Hints defined by this specification should be observed by the provider when possible. When the specific hints that are not recognized by the provider must be ignored. Named query and named queries annotations can be applied to an entity or mapped superclass. Here now we are considering named query in other elements of the entity mappings element in XML overriding rules in XML object relational mapping descriptor. The named query defined by the named query sub-element applies to the persistent unit. The named query defined by the named query sub-element applies to the persistent unit. It is undefined if multiple mapping files for the persistent unit contain named query of the same name. The named query defined is added to the named queries defined in the annotations. if a named query of the same name is defined in the annotations, the named query defined by the sub-element overrides that definition. Now we are considering named native query. The named native query defined by the named native query sub-element applied to the persistent unit. It is undefined if the multiple mapping files for the persistent unit contain named queries of the same name. The named native query defined is added to the named native queries defined in annotations. If the named query of the same name defined in the annotations, the named query defined by the sub-element overrides that definition. Now we are considering the name stored procedure query. The name stored procedure query defined by the name stored procedure query sub-element applied to the persistent unit. It is undefined if the multiple mapping files for the persistent unit contain the named stored procedure queries of the same name. The named stored procedure query defined is added to the named stored procedures queries defined in the annotations. If the named stored in the procedure query of the same name defined in the annotations, the named stored procedure query defined by the sub-element override that definition. Now we are considering named query in sub-elements and attributes. The named query defined by the named query defined by the named query sub-element is added to the named queries defined in annotations and other named queries defined in XML. If the named query of the same name is defined in annotation, the name query defined by the sub-element overrides the definition. If the name query sub-element is present and attributes of sub-element of the named query element are not explicitly specified, their default values are applied. The named query defined by the named query sub-element applies to the persistent unit, and it is defined if multiple mapping files for the persistent unit contain the named queries of the same name. Name native query, then the named query defined by the named native query of sub-element is added to any unnamed queries defined in annotations and other named queries defined in XML. If the named query of the same name is defined in annotations, the named query defined by the sub-element override that definition. If the named native query sub-element is present, the attributes of sub-element of that named native query sub-element are not explicitly specified, their default values are applied. The named native query defined by the named native query sub-element applied to the persistent unit. It is undefined if the multiple mapping files for the persistent unit contain the named queries of the same name. The named stored procedure query. The named stored procedure query defined by the named stored procedure query sub-element is added to any named stored procedure queries defined in annotations and other named stored procedure queries defined in XML. If the named stored procedure query of the same name is defined in the annotations, the named stored procedure query defined by the sub-element override that definition. If the named stored procedure query sub-element is present, the attribute of or sub-element of that named stored procedure query sub-element are not explicitly specified, their default values are applied. The named stored procedure query defined by the named stored procedure query sub-element applied to the persistent unit. It is undefined if the multiple mapping for the persistent unit contain named stored procedure queries of the same name. Example, we can consider illegal state exception. If called for a Jakarta persistent query language update or delete statement in method list get result list in interface query. Now we are focusing on persistence. The jakarta.persistence class contains statics helper methods to obtain EntityManagerFactory instances in a vendor neutral fashion. Within a container, you will typically use injection to access an EntityManagerFactory. Applications operating outside of a container, however, can use the persistent class to obtain EntityManagerFactory objects in a vendor neutral fashion. Here you can see persistent context collision. Only one persistent context could be propagated with Jakarta persistent Jakarta transaction. The extend persistent context would always try to make itself an active persistent context. This can lead to situations which of the two persistent contexts collide with each other. Consider, for example, that a stateless session bean with the transaction scoped EntityManager creates a new persistent context. Then invokes a method on the stateful session bean with the extended persistent context. During the eager associations of the extended persistent context, the container will check to see whether there is already an active persistent context. If there is, it must be the same as the extended persistent context that is trying to associate, or an exception will be thrown. In this example, the stateful session bean will find the transaction scoped persistent context created by the stateless session bean, and the call into the stateful session bean method will fail. There can only one active persistent context for the transaction. This figure illustrates this case. While extended persistent context propagation is useful if a stateful session bean with an extended persistent context is the first enterprise bean to be invoked in a call chain, it limits the situation in which the other components that can call into the stateful session bean if they are also using the entity managers. This might or might not be a common depending on your application architecture, but it is something to keep in mind when planning dependencies between components. One way to work around this problem is to change the default transaction attribute for stateful session bean that uses the extended persistent context. If the default transaction attribute requires new, any active transaction will be suspended before the stateful session bean method starts, allowing it to associate its extended persistent context with the new transaction. This is a good strategy if the stateful session bean calls into other stateless session beans that needs to propagate to the persistent context. Note that excessive use of requires new transaction attribute can lead to application performance problems because many more transactions than normal will be created and the active transaction will be suspended and resumed. If the stateful session bean is largely self-contained, that is, it does not call other session beans and does not need its persistent context propagated, the default transaction attribute of not supported can be worth considering. In this case, any active transaction will be suspended before stateful session bean method start, but two new transaction will be started. If there are some methods that need to write data to the database, those methods can be overridden to use requires new transaction attributes. Here you can see a stateless session bean transaction stateless session bean is connected to stateful session bean via invokes and transaction propagated. Here status session bean interacts with transaction scope persistent context, and here stateful session bean interacts with extended persistence context. Here you can see the collision here. Consider class persistence, bootstrap class that is used to obtain an EntityManagerFactory in Java SE environments. It may also be used to cause schema generation to occur. This is in module jakarta.persistence and in package jakarta.persistence. Here you can see the as an example too, we can consider this the content of example file persistent.xml. A persistence.xml file defines a persistent unit. The persistence.xml is located in meta-inf directory of the root of the persistence unit. It may be used to specify manage persistence classes included in the persistence unit. It may be used to specify manage persistence classes included in the persistence unit, object relational mapping information for those classes, and scripts for use in schema generation and bulk loading of data and other configuration information for the persistence unit and for the entity managers and entity manager factory for the persistence unit. This information may be defined by containment or by reference. Here you can, as an example 3, you can see obtaining an entity manager factory in a Java SE environment. Outside a Jakarta EE container environment, the jakarta.persistence class is the bootstrap class that provide access to an entity manager factory. The application creates an entity manager factory by calling the create entity manager factory method of the Jakarta persistence jakarta.persistence class. The method entity manager factory the method create entity manager factory string persistence unit name here creates and returns an entity manager factory for the named persistence unit. Now we are considering persistent context in entity managers and persistent context. A persistent context is a set of managed entity instances in which for any persistent entity identity there is a unique entity instance. Within a persistent context, entity instances are and their lifecycle are managed by the entity manager. In Jakarta EE environments, a JTA transaction typically involves calls across multiple components. Such components may often need to access the same persistent context within a single transaction. To facilitate such a use of entity managers in Jakarta EE environment, when an entity manager is injected into a component or looked up directly in a JNDI context, its persistent context will automatically be propagated with the current JTA transaction, and the entity manager references that are mapped to the same persistent unit will provide access to the same persistent context within the JTA transaction. This propagation of persistent context by Jakarta EE container avoid the need for application to pass references to the entity manager instances from one component to another. The entity manager for which the container manages the persistent context in this manner is termed container managed entity manager. Container managed entity manager's lifecycle is managed by the Jakarta EE container. In less common use cases with Jakarta EE environment, applications may need to access persistent context that is standalone, that is not propagated along with the JTA transaction across entity manager's references for given persistent unit. Instead, each instance of creating an entity manager causes a new isolated persistent context to be created that is not accessible through the other entity manager references within the same transaction. These use cases are supported by through the entity manager methods of the entity manager factory instance. The entity manager that is used by the application to create and destroy persistent context in this manner is termed as application managed entity manager. An application managed entity manager's lifecycle is managed by the application. Both container managed entity managers and application managed entity managers and their persistent contexts are required to be supported in Java EE web containers and EJB containers. Within an EJB environment, container managed entity managers are typically used. In Java SE environment and Jakarta EE application client containers, only application managed entity managers are required to be. Now we are considering examples in container managed persistent context. This is a container managed extended persistent context. The annotation type persistent context in Jakarta persistent in Jakarta module Jakarta persistence express the dependency on a container managed entity manager and its associated persistent context. Container managed extended persistent context. A container managed extended persistent context can only be initiated within a scope of a stateful session bean. It exists from the point in at which the stateful session bean that declares dependency on an entity manager of the type persistent context type dot extended is created and is said to be bound to the stateful session bean. Dependency on extended persistent context is declared by means of persistent context annotation or persistent context ref deployment descript element. The association of the extended persistent context within JTA transaction is independent of the synchronization type of the persistent context and whether the persistent context has been joined to the transaction. Persistent context is closed by the container when the at remove method of the stateful session bean completes or stateful session bean instance is otherwise destroyed. Here the an extended transaction context is used. The entries may remain managed in the persistent context across multiple transactions. Now we are considering examples in application managed persistent context. Here the application managed persistent context using stateless session bean. When an application managed entity manager is used, an application interact directly with the persistent provider's EntityManagerFactory to manage the entity manager lifecycle and to obtain and destroy persistent context. All such application managed persistent contexts are extended in the scope and can span multiple transactions. The EntityManagerFactory dot create entity manager method and the entity manager clause and its open method are used to manage the lifecycle of the application managed entity manager and its associated persistent context. Extended persistent context exists from the point at which the entity manager has been created using EntityManagerFactory dot create entity manager until the entity manager is closed by the means of EntityManager dot close. An extended persistent context obtained from the application managed entity manager is a standalone persistent context. It is not propagated with the transaction. When JTA application managed entity manager is used, then application managed persistent context may be applied to be type of synchronization type dot unsynchronized. Persistent context of type synchronized type dot unsynchronized is not enlisted in any JTA transaction unless explicitly joined to the transaction by application. The persistent context type synchronized type dot unsynchronized is enlisted in JTA transaction and registered with subsequent transaction notification against the transaction by invocation of entity manager join transaction method. The persistent context remain joined to the transaction until the transaction commit and or rollback. After transaction commit or rollback, the persistent context will not be joined, and any subsequent transaction unless the joint transaction method is invoked in the scope of the subsequent transaction. When JTA application entity manager is used, if the entity manager is created outside the scope of the current JTA transaction, it is responsibility of the application to join the entity manager to the transaction if desired by calling EntityManager.join transaction. If the entity manager is created outside the scope of JTA transaction, it is not joined to the transaction unless EntityManager.join transaction is called. EntityManager.close method closes the entity manager and to release its persistent context and other resources. After calling close, the application must not invoke any further methods on the entity manager instance except for get transaction. Except for get transaction and is open, or the illegal state exception will be thrown. If the close method is invoked when the transaction is active, the persistent context remain managed until the transaction completes. The entity manager is open method indicates whether the entity manager is open. The is open method returns are true until the entity manager has been closed. This is container manager transaction demarcation issues. The session bean creates and closes an entity manager in business method. In each business method. Here persistent unit notation. Remains managed until JTA transaction ends. And now we are considering application managed persistent context in requirements on the container. The container might use the internal APIs to create EntityManagerFactory, or it might use the persistent provider.create container EntityManagerFactory method. The interface persistent provider in package jakarta.persistence.spi in module jakarta.persistence interface implemented by the persistent provider. When application managed persistent context are used, the container must initiate the EntityManagerFactory and expose to the application via JNDI. The container might use the internal API to create the EntityManagerFactory, or it might use the persistent provider.create a container EntityManagerFactory method. However, the container is required to support third-party persistent providers, and in this case, the container must use the persistent provider.create container EntityManagerFactory method to create EntityManagerFactory and the EntityManagerFactory.close method to destroy the EntityManagerFactory prior to the shutdown if it has not been previously closed by the application. Now we are considering provider responsibilities in runtime contract between container and persistent provider. It provides entity managers to the container when requested and registered for transaction synchronization notifications. The provider has no knowledge of the distinction between the transaction scoped and extended persistent context. When EntityManagerFactory.create entity manager is invoked, the provider must create and return a new entity manager. If a JTA transaction is active and the persistent context is the type of synchronization type.synchronize, the provider must register for the synchronization notification against the JTA transaction. When EntityManager.join transaction is invoked, the provider must register for synchronization notification against the current JTA transaction if a previous joint transaction invocation for the transaction has not already been processed. When the JTA transaction commit, if the persistent context is of the type synchronization type.synchronize or has otherwise been joined to the transaction, the provider must flush all modified entity state to the database. When the JTA transaction rollback, the provider must detach all managed entities if the persistent context of the type synchronization type.synchronize or has otherwise been joined to the transaction. Note that the JTA transaction may roll back in the background thread, for example, as a result of transaction timeout, in which case the provider should arrange for the managed entities to be detached from the persistent context but not concurrently while application is on the entity manager invocation. When the provider throws an exception defined to cause transaction rollback, the provider must mark the transaction for rollback if the persistent context is of type transaction type synchronization type.synchronize or has otherwise been joined to the transaction. When the EntityManager.close invoked, the provider should release all resources that may have been allocated after outstanding transaction involving the entity manager have completed. If the entity manager was already in a closed state, the provider must throw the legal exception. When EntityManager.clear is invoked, the provider must detach all managed entities. Now we are considering cache interface. The cache interface provides basic functionality over the persistent provider's second level cache if used. Interface cache in package jakarta.persistent in module jakarta.persistence. Interface is used to interact with the second level cache. If a cache is not in use, the method of this interface have no effect except for contains, which return false. Now we are considering persistent unit util interface. The behavior is undefined if these methods are invoked on an entity instance that is not associated with the persistent unit from whose entity manager factory this interface has been obtained. Persistent unit util interface provide access to utility methods that can be invoked on entities associated with the persistent unit. The interface persistent unit util in package jakarta.persistent in module jakarta.persistence. Utility interface between the application and the persistent provider managing the persistent unit. Now we are considering persistent unit in entity packaging. A persistent unit is a logical grouping that includes an entity manager factory and its entity managers together with their configuration information. Set of managed classes included in the persistent unit and managed by the entity managers of the entity manager factory. Mapping metadata in the form of metadata annotations and or XML metadata that specified the mapping of the classes to the database. Now we are considering persistent.xml file in persistent unit packaging. Here you can see example. Persistent.xml file define the persistent unit. Persistent.xml file located in the meta-inf directory of the root of the persistent unit. It may be used to specify manage persistent classes including the persistent unit. It may be used to specify manage persistent class including the persistent unit, object relation mapping information for those classes, scripts for use for schema generation and bulk loading data. Another configuration information for persistent unit and for the entity managers and entity manager factory for persistent unit. This information may be defined by the container or by reference. Object relational mapping information can be in the form of annotations on the managed persistent classes, including the persistent unit, and ORM .xml contains the meta-inf directory of the root of the persistent unit, one or more XML files on the class path, and referenced from the persistent unit or combination of these. Managed persistent classes may either be contained within the root of the persistent unit, or they may be specified by reference, that is by naming the classes, class archives, or XML mapping files which turn the reference classes. That are accessible on the application class path, or may be specified by some combination of these means. The root element of the persistent.xml is the persistent element. The persistent element consists one or more persistent unit elements. Persistent unit element contains name, transaction type, attributes, and the following sub-element: description, provider, JTA data source, non-JTA data source, mapping file, jar file, class, exclude unlisted classes, shared cache mode, validation mode, and properties. The name attribute is required. The other attributes and elements are optional. The semantics are described. You can see the examples here. The name attribute defines the name of the persistent unit, and this name may be used to identify persistent unit referenced by the persistent context and persistent unit annotations, and in the programmatic API for creating the EntityManagerFactory. Transaction type is not shown here. Transaction type attribute is used to specify whether the entity managers provided by the EntityManagerFactory for the persistent unit must be JTA entity managers or resource local entity managers. The value of the element is JTA or resource underscore local. Transaction type JTA assumes that the JTA resource JTA data source will be provided and either specified by the JTA data source element or provided by the container. In general, the Jakarta E environments, the transaction type of resource underscore local assumes that non-JTA data source will be provided. In Jakarta E environment, if this element is not specified, the default is JTA. In Java SE environment, if this element is not specified, the default is resource underscore local. Description. The description element provides optional descriptive information about the persistent unit. Provider. The provider element specifies the name of the persistent provider's jakarta.persistent.spa.persistent provider class. The provider element is optional but should be specified if the application is depending upon the particular persistent providing being used. JTA data source and non-JTA data source. In Jakarta E environments, the JTA data source and non-JTA data source elements are used to specify the JNDI name and of the JTA and or non-JTA data source to be used by the persistent provider. If neither is specified, the deployer must specify the JTA data source at the deployment, or default JTA data source must be provided by the container, and the JTA EntityManagerFactory will be created to correspond to it. In Java SE environment, these elements may be used used data source information may be specified by the other means depending upon the requirement of the provider. Mapping file, jar file, class, and exclude unlisted classes. The following classes must be implicitly or explicitly denoted as managed persistent classes to be encoded within the persistent unit. Entity classes, embedded classes, map super classes, converter classes. Set of managed persistent classes that are managed by the persistent unit is defined by one or more of the following. Annotated managed persistent class contained in the root of the persistent unit, unlike exclude unlisted classes element is specified. One or more object relational mapping XML files. One or more jar files that will be a search for classes, and an explicit list of classes. The set of entities managed by persistent unit is a union of these sources with the mapping metadata annotation. So annotation default for a given class being overridden by XML mapping information file if there are both annotations as well as XML mappings for the class. Minimum portable level of overriding is at the level of the persistent field or property. Class and or jar files are named as part of the persistent unit must be on the class path. Referencing them from the persistent.xml file does not cause them to be placed on the class path. All classes must be on the class path to ensure that the entity managers from the different persistent unit that map the same class will be accessed the same identical class. Shared cache mode is not shown here. The shared cache mode element determines whether the second level cache is in effect or not. In effect for the persistent unit. Validation mode element determines whether the automatic lifecycle event time validation in effect. Properties element is used to specify both standard and vendor specific properties and hint to that apply to the persistent unit and its EntityManagerFactory configuration. This section provides the schema XML schema for the persistent.xml file here and etc. We are considering Jakarta E deployment in container and provider contracts for deployment and bootstrapping. Once the container has read the persistent metadata, it determines the Jakarta SPI persistence provider implementation for class for each deployed named persistent unit. Interface persistent provider in package jakarta.persistent.spi in module jakarta.persistent. It is invoked by the container, the Jakarta environment, and by the persistent class in the Java SC environment to create an EntityManagerFactory and or to cause schema generation to occur. Each persistent unit deployed into Jakarta E container consists of a single persistent.xml file, a number of mapping files, and a number of class files. At deployment time, the container is responsible for scanning the locations and discovering the persistent.xml files and processing them. When the container finds the persistent.xml file, it must process the persistent unit definitions that it contains. The container must validate the persistent.xml file against the persistence 30.xsd or persistent22.xsd schema in accordance with the version specified by the persistent.xml file, and the report any validation errors. Provider or data source information not specified in the persistent.xml file must be provided at deployment time or defaulted by the container. The container may optionally add any container specific properties to be passed to the provider when creating the EntityManagerFactory for the persistent unit. Once the container has read the persistent metadata, it determines the jakarta.persistence.spi.persistent provider implementation class for each deployed named persistent unit. The container then creates an instance of the persistent provider implementation class for each deployed named persistent unit and invokes a create container EntityManagerFactory method on that instance. Container must implement the persistent unit info interface and pass metadata in the form of a persistent unit info instance to the persistent provider as part of this call. If the bean validation provider exists in the container environment and the validation mode none is specified, the validator factory instance must be made available by the container. The container is responsible for passing the validator factory instance via the map that is passed as an argument to the create container EntityManagerFactory call. The map key used to be must be the standard property name jakarta.persistence.validation.factory. If CDI is enabled, the bean manager instance must be made available by the container. The container is responsible for passing this bean manager instance via the map that is passed as an argument to the create container EntityManagerFactory call. The map key used must be the standard property name jakarta.persistence.bean.manager. The EntityManagerFactory instance obtained as a result will be used by the container to create container managed entity managers. If one EntityManagerFactory is permitted to be created for each deployed persistent unit configuration, a number of EntityManager instances may be created from the given factory. In Jakarta E environment, the classes of the persistent unit should not be loaded by the application class loader or any of its parent class loaders until after EntityManagerFactory for the persistent unit has been created. When a persistent unit is redeployed, the container should call the close method and on the previous EntityManagerFactory instance and call the create container EntityManagerFactory method again with the required persistent unit info metadata to achieve the redeployment. Now we are considering bootstrapping in Java SE environment. Here the example, the jar include the provider configuration file. In Java SE environment, the persistent.create EntityManagerFactory method is used by the application to create EntityManagerFactory. A persistent provider implementation running in a Java SE environment should also act as a service provider by supplying a service provider configuration file as defined by the Java SE platform. The provider configuration file serves to expose the provider implementation class to the persistent bootstrap class, positioning provider as a candidate for backing named persistent unit. The provider supplies the provider configuration file by creating a text file named jakarta.persistence.spi.persistent provider and placing in the meta-inf services directory of one of its jar files. The content of the file should be the name of the provider implementation class of the jakarta.persistence.spi.persistent provider interface. Example here, the persistent vendor called ACME persistent product ships in a jar called acme.jar that contains its persistent provider implementation. The jar includes the provider configuration file. The content of the meta-inf services jakarta.persistence.spi.persistent provider file is nothing more than the name of the implementation class com.acme.persistent provider. Persistent provider jars may be installed or made available in the same ways as other service providers. For example, extensions or added to the application path. Persistent bootstrap class must locate all the persistent providers using persistent provider resolver mechanism and call create EntityManagerFactory on them in turn until an appropriate backing providers return the EntityManagerFactory instance. Provider may deem itself as appropriate for the persistent unit if any of the following are true. Implementation class has been specified in the provider element for that persistent unit in the persistent.xml file and has not been overridden by the different jakarta.persistent.provider. Property value included in the map passed to the create EntityManagerFactory method. The jakarta.persistent.provider property was included in the map passed to the create EntityManagerFactory, and the value of the property is provider implementation class. No provider was specified for the persistent unit in either the persistent.xml or property map. If the provider does not qualify as a provider for the named persistent unit, it must return null when create EntityManagerFactory is invoked on it. Now we are considering determining the available persistent providers. The persistent provider resolver and persistent provider resolver holder mechanism support the dynamic discovery of persistent providers. The persistent provider resolver instance is responsible for returning a list of providers available in the environment. Here the interface persistent provider resolver in package jakarta.persistent.spi in module jakarta.persistence. Determine the list of persistent providers available in the runtime environment. Class persistent provider resolver holder in package jakarta.persistent.spi in module jakarta.persistence. Hold the global persistent provider resolver instance. If no persistent provider resolver is set by the environment, the default persistent provider resolver is used. Enable jakarta.persistent.spi logger to show diagnostic information. Implementations must be thread safe. Persistent provider resolver instance is responsible for returning a list of providers available in the environment. Persistent provider resolver holder class hold the persistent provider resolver instance that is in use. The implementation of persistent provider resolver holder must be thread safe, but no guarantee is made against the multiple thread setting the resolver. Container is allowed to implement and set a specific persistent provider resolver provided that respect the persistence provider resolver contract. Persistent provider resolver instance is to be used to set the is set by the container using the persistent provider resolver holder dot set persistent provider resolver method. If no persistent provider resolver is set, the persistent provider resolver holder must return a persistent provider resolver that returns the providers whose persistent provider jars has been installed or made available as service providers and extensions. The default persistent provider resolver instance does not guarantee the order in which the persistent providers are returned. Persistent provider resolver must be thread safe. Persistent provider resolver get persistent providers method must be used to determine the list of available persistent providers. The result of calling persistent provider resolver holder get persistent provider resolver and the persistent provider resolver get persistent providers method must not be cached. In particular, the following method must use the persistent provider resolver instance returned by the persistent provider resolver holder get persistent provider resolver method to determine the list of available providers. Persistent.create EntityManagerFactory string. Persistent.create EntityManagerFactory string map. Persistent util.is loaded object. Persistent util is loaded object string. This method must not cache the list of providers and must not cache the persistent provider resolver instance. Note that the persistent provider resolver get persistent providers method can potentially be called many times. It is therefore recommended that the implementation of this method make use of caching. Note that only single persistent provider resolver instance can be defined in a given class loader hierarchy at given time. Now we are considering jakarta.persistent.schema-generation.database.action in schema generation. The jakarta.persistent.schema-generation database action database.action property specified the action to be taken by the persistent provider with regard to the database artifacts. The values for this property are none, create, drop, and create, drop. If the jakarta dot persistent dot schema dash generation dot database dot action property is not specified, the schema generation actions must be taken on the database. Now we are considering the jakarta.persistent.spi.persistent provider in responsibilities of the persistent provider. The persistent provider implementation class must have a public no arg constructor. The interface persistent provider in package jakarta.persistent.spi in module jakarta.persistent. The interface implemented by the persistent provider. The interface jakarta.persistent.spi.persistent provider must be implemented by the persistent provider. It is invoked by the container in the Jakarta E environment and by the jakarta.persistent.persistence class in the Java SC environments. The jakarta.persistent.spi.persistent provider implementation is not intended to be used by the application. The persistent provider implementation class must have a public no arg constructor. The properties used in the create EntityManagerFactory method in Java SC environment are described in the documentation. You can refer it. Now we are considering jakarta.persistent.spi.persistent unit info interface. Interface persistent unit info in package jakarta.persistent.spi in module jakarta.persistence. Interface implemented by the container and used by the persistent provider when creating an EntityManagerFactory. Now we are considering persistent util interface. The semantics of the method of this interface are defined. The interface persistent util in package jakarta.persistence in module jakarta.persistence. Utility interface between the application and the persistent providers. This interface is used to determine the load state. Now we are considering evicting an entity instance from the persistent context in entity instance lifecycle and entity operations. The semantics of the detach operation applied to an entity X as follows. The entity instance is removed from the persistent context by invoking detach method on it or cascading the detach operation. Changes made to the entity and if any, including removal of the entity, will not be synchronized to the database after such eviction has taken place. Applications must be flushed method use the flush method prior to the detach method to ensure the portable semantics if changes have been made to the entity, including removal of the entity. Because the persistent provider may write to the database at times other than the explicit invocation of the flush method, portable applications must not assume that changes have been written to the database if the flush method has not been called prior to detach. The semantics of the detach operation applied to an entity X are as follows. If X is a managed entity, the detach operation causes it to become detached. Detach operation is cascaded to entities referenced by X if the relationship from X to these entities is annotated with the cascade equal detach or cascade equal all annotation element value. Entities which previously referenced X will continue to reference X. If the X is a new or detached entity, it is ignored by the detach operation. If the X is a removed entity, the detach operation causes it to become detached. Detach operation is cascaded to entities referenced by X if the relationship from X to these other entities is annotated with the cascade equal detach and cascade equal all annotation element value. Entities which previously reference X will continue to reference X. Portable applications should not pass removed entities that have been detached from the persistent context to further entity manager operations. Now we are considering persistent context lifetime and synchronization type in entity operations. The persistent context lifetime scope is defined when the entity manager instance is created, whether explicitly or in conjunction with injection or JNDI lookup. Persistent context type in package jakarta.persistence in module jakarta.persistence specified whether a transaction is scoped or extended persistent context is to be used in persistent context. If not specified, the transaction is scoped, persistent context is used. The lifetime of a container managed persistent context can either be scoped to a transaction is scope persistent context, or have a lifetime scope that extend beyond that of a single transaction extended persistent context. The enum persistent context type is used to define the persistent context lifetime scope for a container managed entity managers. Persistent context lifetime scope is defined when the entity manager instance is created, whether explicitly or in conjunction with the injection or JNDI lookup. By default, the lifetime of a persistent context of a container managed by the entity manager correspondent to a scope of a transaction, that is, it is of type persistent context type dot transaction. When an extended persistent context is used, the extended persistent context exists from the time the entity manager instance is created until it is closed. This persistent context might span multiple transactions and non-transactional invocations of the entity manager. An entity manager with an extended persistent context maintain its reference to the entity object after a transaction has committed. Those objects remain managed by the entity manager and they can be updated as managed objects between transactions. Navigation from managed object in an extended persistent context result in one or more other managed object regardless of whether a transaction is active. When an entity manager with an extended persistent context is used, the persist and remove, merge and refresh operations can be called regardless of whether the transaction is active. Effect of these operations will be committed to the database when the extended persistent context is enlisted in a transaction and transaction commits. The scope of the persistent context of an application managed entity manager is extended. It is responsible for the application to manage the lifecycle of the persistent context. Container managed persistent context are described further in the documentation, and persistent context managed by the applications are also described further in the documentation. Now we are considering persistent default sub-elements in XML, overriding rules in XML object relational mapping descriptor. Schema. The schema of a sub-element applies to all entities, tables, secondary tables, join tables, collection tables, table generators, and sequence generators in the persistent unit. The schema sub-element is overridden by the schema sub-element of the entity mapping element. Any schema element explicitly specified in the table or secondary table annotation on an entity, or any schema attributes on any table or secondary table sub-element defined within the element entity element. Any schema element explicitly specified in the table generator annotation or table generator sub-element. Any schema element explicitly specified in the sequence generator annotation or sequence generator sub-element. Any schema element explicitly specified in the join table annotation or join table sub-element. And any schema element explicitly specified in the collection table annotation or collection table sub-element. An example, we can consider persistence exception. If insufficient or inconsistent configuration information is provided, or if schema generation otherwise fails in method generate schema string persistent unit name map in class persistence. Now we are focusing on entity. Entities are persistent objects that represent data store records. An entity is a lightweight persistent domain object. Here you can see a the life cycle of an entity with respect to the APIs. Here you can see the entity manage operations for managing an entity instances life cycle. An entity instance can be characterized as being new, managed, detached, and removed or removed. New entity instance has no persist identity and is not yet associated with the persistence context. A managed entity instance is an instance with a persistent identity that is currently associated with the persistence context. Detached entity instance is an instance with a persistent identity that is not or no longer associated with the persistent context. A removed entity instance is an instance with a persistent identity associated with the persistence context that will be removed from the database upon transaction commit. Here the use of the cascade annotation element may be used to propagate the effect of an operation to associated entities. The cascade functionality is most typically used in parent-child relationships. Entity instances are created by means of the new operation. An entity instance, when first created by new, is not yet persistent. An instance becomes persistent by means of the EntityManager API. Persisting an entity instance, a new entity instance become both managed and persistent by invoking the persist method on it or by cascading the persist operation. Semantics of the persist operation applied to an entity X are as follows. If X is a new entity, it becomes managed. The entity X will be entered into the database at or before transaction commit or as a result of flush operation. If X is a pre-existing managed entity, it is ignored by the persist operation. However, the persist operation is cascaded to entities referenced by X. If the relationships from X to these other entities are annotated with the cascade equal persist or cascade equal all annotation element value or specified with the equivalent XML descriptor element. If X is a removed entity, it becomes managed. If X is a detached object, the entity exception may be thrown when the persistent operation is invoked, or entity exception or another persistent exception may be thrown at flush or commit time. For all other y referenced by a relationship from X, if the relationships to Y has been annotated with the cascade element value cascade equals persist or cascade equal all, the persist operation is applied to Y. Removal. A managed entity instance becomes removed by invoking remove method on it, or by cascading the remove operation. The semantics of the remove operation applied to an entity X are as follows. If X is a new entity, it is ignored by the remove operation. However, the remove operation is cascaded to entities referenced by X if the relationship from X to these other entities are annotated with the cascade equals remove or cascade equals all annotation element value. If X is a managed entity, the remove operation causes it to become removed. The remove operation is cascaded to entities referenced by X if the relationships from X to these other entities are annotated with cascade equal remove or cascade equal all annotation element value. If X is a detached entity, an illegal argument argument exception will be thrown by the remove operation, or the transaction commit will fail. If X is a removed entity, it is ignored by the remove operation. A removed entity X will be removed from the database at or before transaction commit. Or as a result of flush operation. After an entity has been removed, its state, except for generated state, will be that of the entity at the point at which the remove operation was called. Detached entities. Detached entity results from transaction commit if a transaction scope persistence context is used from transaction rollback from detaching the entity from persistent context, from clearing the persistent context, from closing an entity manager, or from serializing an entity, or otherwise passing an entity by value to a separate application tier through a remote interface, etc. Detached entity instances continue to live outside of the persistence context in which they were persisted or retrieved. Their state is no longer guaranteed to be synchronized with the database state. The application may access the available state of available detached entity instances after the persistence context ends. The available states includes any persistent field or property not marked lazy, fetch equals lazy, any persistent field or property that was accessed by the application of fetch by means of an entity graph. If the persistent field or property is an association, the available state of an associated instance may only be safely accessed if the associated instance is available. The available instances include any entity instance retrieved by using find method, any entity instances retrieved by using a query or explicitly requested by in a fetch join, any entity instance for which an instance variable holding non-primary key persistent state was accessed by the application, any instance that can be reached from another variable instance by navigating associations marked fetch equal eager. Here you can see new transient. New transient is new transient interacts with managed. Persist is passed from new transient to manage, and rollback new is passed from manage to new transient. Rollback is an extended persistence context. Manage interacts with new transient, and removed and detached. Refresh is passed from managed to managed. Remove is passed from managed to removed. Persist, rollback passed from removed to managed. Rollback here is an extended persistence context. Commit, rollback clause are passed from managed to detached, and merge is passed from detached to managed. Here detached interact with managed, and removed interacts with managed. Remove is connected to new transient. Commit is passed from remove to new transient. Remove is connected to detached. Rollback is passed from remove to detached. Here you can see entity and relational database table relation. An entity is a persistent domain object. Each entity represents a table in a relational database, and each entity instance corresponds to a row in a table in that table. Jakarta persistence uses annotations of XML to map entities to a relational database. The persistent state of an entity fields or properties, setter and getter methods use object relational mapping annotations to map the entities and entity relationships to the data, the relational data in the underlying data store. Here you can see each entity represent a table in a relational database, and each entity instance represent a table row in a relational database. As an example, we can consider annotation type entity. Specified that the class is an entity. This annotation is applied to the entity class. This is in module jakarta.persistence and package jakarta.persistence. As an example 2, we can consider this code segment, creating an employee entity. Here the annotation type ID specifies the primary key of an entity. The field or property to which the ID annotation is applied should be one of the following types: any Java primitive type, any primitive wrapper type, string java.util.date, java.sql.date, java.math.bigdecimal, java.math.biginteger. Here the annotation type generated value provides for the specification of generation strategies for the values of primary keys. As an example 3, we can consider this code segment. Mapping of derived identities. Here the dependent entity uses ID class to represent a composite key. The annotation type ID specifies the primary key of an entity. The field or property to which the ID annotation is applied should be one of the following types: any Java primitive type, any primitive wrapper type, string java.util.date, java.sql.date, java.math.bigdecimal, java.math.biginteger. The mapped column or for the primary key of the entity is assumed to be the primary key of the primary table. If no column annotation is specified, the primary key column name is assumed to be the name of the primary key property or field. So here the string name matches the name of the ID attribute. Long emp matches the name of the ID attribute and the type of the employee primary key. And here the ID attribute mapped by join column default. As an example 4, we can consider this code segment bidirectional one-to-one relationships. Here the annotation type one-to-one specifies a single valued association to another entity that has one-to-one multiplicity. It is not normally necessary to specify the associated target entity explicitly, since it can usually be inferred from the type of the object being referred. If the relationship is bidirectional, the non-owning side must use the mapped by element of the one-to-one annotation to specify the relationship field or property of the owning side. Here, assuming that entity A here references a single instance of entity B, and entity B references a single instance of entity A. Entity A is specified as the owner of the relationship. The following mapping defaults apply. Entity A is mapped to a table named A, then entity B should map to a table named B. Table A contains a foreign key to table B. The foreign key column name is formed as the concatenation of the following: the name of the relationship property or field of entity A, underscore the name of the primary key column of the table B. The foreign key column has the same type as the primary key of the table B, and there is a unique key constraint on it. Here, similarly, entity employee references a single instance of entity cubicle, and entity cubicle references a single instance of entity employee. The entity employee is the owner of the relationship. The following mapping defaults apply here. The entity employee is mapped to a table named employee. Entity cubicle is mapped to a table named cubicle. Table employee contains a foreign key to table cubicle. The foreign key column is named assigned cubicle. Underscore primary key of cubicle, where primary key of cubicle denotes the name of the primary key column of the table cubicle. The foreign key column has the same type as the primary key of cubicle. There is a unique key constraint on it. As an example 5, we can consider bidirectional many-to-one and one-to-many relationships. The annotation type many-to-one specifies a single valued association to another entity class that has many-to-one multiplicity. It is not normally necessary to specify the target entity explicitly, since it can usually be inferred from the type of the object being inferred, referenced. If the relationship is bidirectional, then non-knowing one-to-many entity side must use the mapped by element to specify the relationship field or property of the entity that is the owner of the relationship. Here annotation type one-to-many specified a many valued association with one-to-many multiplicity. Here entity employee references a single instance of entity department. The entity department references a collection of entity employee. The entity employee is the owner of the relationship. The following mapping defaults apply. The entity employee is mapped to a table named employee. The entity department is mapped to a table named department. The table employee contains a foreign key to the table department. The foreign key column is named department underscore primary key of the department, where primary key of the where primary key of the department denotes the name of the primary key column of the table department. The foreign key column has the same type as the primary key department. As an example 6, we can consider unidirectional one-to-one relationships. The annotation type one-to-one specifies a single valued association to another entity that has one-to-one multiplicity. It is not normally necessary to specify associated target entity explicitly, since it can usually be inferred from the type of the object being referenced. If the relationship is bidirectional, the non-knowing side must use the mapped by element of the one-to-one annotation to specify the relationship field or property of the owning side. Here the entity employee references a single instance of entity travel profile. Entity travel profile does not reference entity employee. The entity employee is the owner of the relationship. The following mapping defaults apply here. The entity employee is mapped to a table named employee. The entity travel profile is mapped to a table named travel profile. The table employee contains a foreign key to table travel profile. The foreign key column is named profile underscore primary key of travel profile, where primary key of the travel profile denotes the name of the primary key column of the table travel profile. Foreign key column has the same type as the primary key of the travel profile, and there is a unique key constraint on it. As an example 7, we are considering unidirectional many-to-one relationships. The annotation type many-to-one specifies a single valued association to another entity class that has many-to-one multiplicity. It is not normally necessary to specify the target entity explicitly, since it can usually be inferred from the type of the object being referenced. If the relationship is bidirectional, then unknowing one-to-many entity side must use the mapped by element to specify the relationship field or property of the entity that is the owner of the relationship. Here the entity employee references a single instance of entity address. An entity address does not reference entity employee. Entity employee is the owner of the relationships. The following mapping defaults apply. The entity employee is mapped to a table named employee. Entity address is mapped to a table named address. The table employee contains a foreign key to table address. The foreign key column is the name of the address underscore primary key of address, where the primary key of address denotes the name of the primary key column of the table address. The foreign key column has the same type as the primary key of the address. As an example 8, we can consider this one, the bidirectional many-to-many relationships. The annotation type many-to-many specifies many valued association with many-to-many multiplicity. Here the entity project references a collection of entity employees. The entity employee references a collection of entity project. The entity project is the owner of the relationship. The entity project is mapped to a table named project. These are the mapping defaults now. The entity employee is mapped to a table named employee. And there's a joint table that is named project underscore employee owner name first. This joint table has two foreign key columns. The one foreign key column refers to the table project and has the same type as the primary key of project. The name of this foreign key column is project primary key of project, where the primary key of project denotes the name of the primary key column of table underscore project. The other foreign key column refers to the table employee and has the same type as the primary key of employee. The name of this foreign key column is employees primary key of employee, where primary key of employee denotes the name of the primary key column of table underscore employee. As an example 9, we can consider this one, unidirectional one-to-many relationships. The annotation type one-to-many specifies many valued association with one-to-many multiplicity. The entity employee references a collection of entity annual review, and entity annual review does not reference entity employee. Entity employees is the owner of the relationships. The following mapping defaults apply here. The entity employee is mapped to a table named employee. Entity annual review is mapped to a table named annual review. There's a joint table that is named employee underscore annual review. The owner name first. This joint table has two foreign key columns. One foreign key column refers to the table employee and has the same type as the primary key of employee. The foreign key column is named employee, primary key of employee, where primary key of employee denotes the name of the primary key column table of underscore employee. The other foreign key column refers to the table annual review and has the same type as the primary key of annual review. This foreign key column is named annual reviews, primary key of annual review, where primary key annual review denotes the name of the primary key column of table underscore annual review. There is a unique key constraint on the foreign key that refers to annual review. As an example 10, we can consider this one, this code segment, unidirectional many-to-many relationship. Here the annotation type many-to-many specified a many-valued association with many-to-many multiplexity. The entity employee here references a collection of patent. The entity patent does not reference entity employee. Entity employee is the owner of the owner of the relationship. The following mapping defaults apply here. Entity employee is mapped to a table named employee. Entity patent is mapped to a table named patent. There is a joint table that is named employee underscore patent. Owner name first. This joint table has two foreign key columns. One foreign key column refers to the table employee and has the same type as the primary key of employee. The foreign key column is named employee, primary key of employee, where primary key of employee denotes the name of the primary key column of the table underscore employee. The other foreign key column refers to the table patent and has the same type as the primary key of patent. This foreign key column is named patent's primary key of patent, where primary key of patent denotes the name of the primary key column of the table underscore patent. As an example 11, we can consider abstract class as an entity. The annotation type inheritance specifies the inheritance strategy to be used for an entity class hierarchy. It is specified on the entity class, that is the root of the entity class hierarchy. If the inheritance annotation is not specified or no inheritance type is specified for the entity class hierarchy, the single underscore table mapping strategy is used. Here an abstract class can be specified as an entity. An abstract entity differs from a concrete entity only in that it cannot be directly instantiated. An abstract entity is mapped as an entity and can be the target of queries which will operate over and or retrieve instances of its concrete subclasses. Here the annotation type entity is specified that the class is an entity, and this annotation is applied to the entity class. Here annotation type table specifies the primary table for the annotated entity. The additional tables must be specified using secondary table or secondary tables annotation. Here the annotation type discriminator value specifies the value of the discriminator column for entities of the given type. Here the annotation type primary key join column specifies the primary key column that is used as a foreign key to join to another table. Here the inherit EMP ID, but the mapped in this class to ft underscore emp dot ft underscore emp id. Inherit version map to emp dot version, and inherit address map to emp dot address fk. Default to ft underscore emp dot salary here, and here the primary key column is pt underscore emp dot emp id due to primary key join column default. As an example 12, we can consider concrete class as a mapped superclass. The annotation type mapped superclass designate the class whose mapped information is applied to the entities that inherit from it. A mapped superclass has no separate table defined for it. Here the annotation type join column specifies the column for joining an entity association or element collection. If the join column annotation itself is defaulted, a single join column is assumed and the default values apply. Here the annotation type association override is used to override the mapping of for an entity relationship. Here name is required, and the name of the relationship property whose mapping is being overridden if the property based access is being used, or the name of the relationship field if field based access is used. Here join columns, the join columns being mapped to the persistent attributes. Here the default table is here emp ft employee, and here the inherited emp id field mapped to ft employee dot emp id. Here the inheritance version field mapped to ft employee dot version. Here the inheritance address field mapped to ft employee dot addr fk, and the defaults to ft employee dot salary here. Here the inheritance inheritant emp field mapped to pt underscore emp dot empid. Here inheritance field is mapped to pt underscore emp dot version, and here address field is mapping address field mapping overridden to pt underscore emp dot addr underscore id fk. As an example 13, we can consider this code segment non-entity superclass. An entity can have non-entity superclass which may be either concrete or abstract class. And here operation count is in transient state. As an example 14, we can consider naming of database objects. Here the annotation type table specifies the primary table for the annotated entity. Additional tables may be specified using secondary table or secondary tables annotations. Now we are considering entity class, the entity class in entities. The entity class must be annotated with an entity annotation or denoted in the XML descriptor as an entity. The annotation type entity in package jakarta.persistence in module jakarta.persistence specified that the class is an entity and this annotation is applied to the entity class. The entity class must be annotated with the entity annotation or denoted in the XML descriptor as an entity. The entity class must have a no-arg constructor. The entity class may have other constructors as well. The no-arg constructor must be public or protected. The entity class must be a top-level class, and enum or interface must not be designated as an entity. Entity class must entity class must be top-level class. Enum or interface must not be designated as an entity. Entity class must not be final. No method or persistent instance variable of the entity class may be final. An entity, if an entity instance is to be passed by the value as detached object, for example through a remote interface, the entity class must implement the serializable interface. Entity support inheritance. Entities support inheritance, polymorphic associations, and polymorphic queries. Both abstract and concrete classes can be entities. Entities may extend non-entity classes as well as entity classes, and non-entity classes may extend entity classes. The persistent state of an entity is represented by instance variables, which may correspond to Java Beans properties. An instance variable must be directly accessed only from within the method of an entity by the entity instance itself. Instance variables must not be accessed by the client of the entity. The state of the entity is available to the client only through the entity's methods, that is accessor methods, getter or setter methods, or other business methods. Here you can see, here we are considering persistent fields and properties. You can see the example here. No arg constructor, property accessed is used. Business methods to add phone number to the customer. update the phone entity instance to refer to this customer. Now we are considering default access type. In access type, the access type is explicitly specified by means of the access annotation. The annotation type access in package jakarta.persistence in module jakarta.persistence used to specify an access type to be applied to an entity class, mapped superclass to embeddable class, or to the specific attribute of such a class. By default, the single access type field or property access applies to an entity hierarchy. The default access type of an entity hierarchy is determined by the placement of mapping annotation on the attributes of the entity classes and mapped superclasses of the entity hierarchy that do not explicitly specify the access type. The access type is explicitly specified by the means of access annotation. When annotations are used to define the default access type, the placement of the mapping annotations on either of persistent field or persistent properties of the entity class specify the access type as being either field or property based access respectively. When the field-based accessories use the object relational mapping annotations for the entity class annotate the instance variable, and the persistent provider runtime access the instance variable directly. All non-transient variable instance variables that are not annotated with the transient annotations are persistent. When the property-based access is used, the object relational mapping annotations for the entity class annotate the getter property accesses, and the persistent provider runtime access persistent state via the property access methods. All properties not annotated with the transient annotation are persistent. Mapping annotations must not be applied to the field or properties that are transient or transient. All such classes in the entity hierarchy whose access type is defaulted in this way must be consistent in their placement of annotations on either field or property such that single consistent default access type applied within the hierarchy. Any embeddable classes used by such classes will have the same access type as the default access type of the hierarchy unless access annotation is specified as defined below. It is an error if the default access type cannot be determined and access type is not explicitly specified by means of annotations or the XML descriptor. The behavior of the applications that mix the placement of annotation on fields and properties within the entity hierarchy without explicitly specifying the access annotation is undefined. Now we are considering primary keys corresponding to derived identities. Examples of derived identities in primary keys and entity identity. Dependent entity uses ID class to represent a composite key. The annotation type ID class in package jakarta.persistence in module jakarta.persistence they specify the composite primary key class that is mapped to the multiple fields or properties of the entity. The identity of an entity may be derived from the identity of another entity, the parent entity. When the form entity, the dependent entity, is the owner of the many-to-one or one-to-many relationships to the parent entity. And the foreign key maps the relationship from dependent entity. If many-to-one or one-to-many relationship correspond to the primary key attributes, the entity contained in this relationship cannot be persisted without the relationship having been assigned to entity, since the identity of the entity contained in the relationship is derived from the reference identity. Reference entity. Derived entities. The derived identities may be captured by means of simple primary keys or by means of composite keys. If the dependent entity class has the primary key attributes in addition to the those correspond to the parent's primary key, or if the parent has the composite key and the embedded ID or ID class must be used to specify the primary key of the dependent entity. It is not necessary that parent entity and the dependent entity both use the embedded IDs or both use the ID classes to represent composite primary keys when parent has composite key. A dependent entity may have more than one parent entity. Here you can see the examples of derived identities. The parent entity has a simple primary key here. The dependent entity uses ID class to represent the composite key. This is the sample query. Matches the name of the at ID attribute. Matches the name of that ID attribute and the type of the employee PK. ID attributes mapped by join column default. Now we are considering basic type. Basic type is any Java primitive type, wrap of the primary types, Java wrap of the primitive types, java.long.string, java.math.biginteger, java.math.bigdecimal, java.math.util.date, java.util.calendar, java.util.sql.date, java.sql.time, java.sql.timestamp, java.time.localDate, java.time.localTime, java.time.localDate time, java.time.offset time, java.time.offset date time, byte array, byte array, character array, enum, any other type that implements serializable. Now we are considering embeddable classes. An entity may have collections of embeddables as well as single valued embeddable attributes. The annotation type embeddable in package jakarta.persistence in module jakarta.persistence specified the class whose instances are stored as an instrict part of an owning entity as a share the identity of the entity. Each of the persistent properties or field of the embedded object is mapped to the database table for the entity. An entity may use other fine-grained classes to represent entity state. Instances of these classes, unlike entity instances, do not have persistent identity of their own. Instead, they exist only as part of the state of the entity to which they belong. An entity may have collections of embeddables as well as single-valued embeddable attributes. Embeddables may also be used as map key and maps values. Embedded objects belong strictly to their owning entity and are not shareable across persistent entities. Attempting to share an embedded object across entities has undefined semantics. Embeddable classes must adhere to the requirement specified in the specification for entities, with the exception that embeddable classes are not annotated as entity. Embeddable classes must be annotated as embeddable or denoted in XML script as such. Embeddable class may be used to represent a state of another embeddable class. The embeddable class, including an embeddable class within another embeddable class, may contain a collection of basic type or other embeddable class. An embeddable class may contain a relationship to any entity or collection of entities. Since the instances of embeddable classes themselves have no persistent identity, the relationship from the reference entity is to entity that contain embeddable instances are not to the embeddable itself. The embeddable class that is used as an embedded ID or as a mapped key must not contain such a relationship. Additional requirements and restrictions on embedded classes are described in the documentation. Now we are considering collections of embeddable classes and basic types. Such a collection, when specified, such as by the element collection annotation, is mapped by the means of a collection table. The annotation type element collection in package jakarta.persistence in module jakarta.persistence specifies a collection of instances of a basic type or embeddable class must be specified if the collection is to be mapped by means of a collection table. A persistent field or property of an entity or embeddable class may correspond to a collection of basic type or embeddable class element collection. Such a collection, when is specified as such by the element collection annotation, is mapped by the means of collection table. If the element collection annotation or XML equivalent is not specified for the collection value field property, the rules in the documentation apply. That embeddable class, including an embeddable class within another embeddable class that is contained within the element collection, must not contain an element collection, nor may it contain relationship to another relationship to an entity other than many one-to-one or many-to-one or one-to-one relationship. The embeddable class must be on the owning side of such a relationship, and relationship must be mapped by the following key mapping. Now we are considering map keys in map collections. If a map key type is a basic type, the map key column annotation can be used to specify the column mapping for the primary key. The annotation type map key column in package jakarta.persistence in module jakarta.persistence specify the mapping for the key column of the map whose map key is the basic type. The name element is not specified. It defaults to the concatenation of the following: the name of the referencing relationship field or property, underscore key or semicolon key. If the map key type is basic type, the map key column annotation can be used to specify the column mapping for the map key. If the map key column annotation is not specified, the default values of the map key column annotation apply. If the map key type is embeddable class, the mapping for the map key columns are defaulted according to the default column mappings for the embeddable class. The attribute override and attribute overrides annotation can be used to override these mappings. If an embeddable class is used as a map key, the embeddable class must implement the hash code and equals method consistently with the database columns to which the embeddable is mapped. If the map key type is an entity, map key join column and map key join columns annotations are used to specify the column mapping for the map key. If the primary key of the reference entity is a simple primary key and the map key join column annotation is not specified, the default values for the map key join column annotation apply. If a Java generic types are not used in the declaration of relationship attributes of type java.util.map, the map key class annotation must be used to specify the type of the key of the map. The map key annotation is used to specify the special case where the map key is itself a primary key and persistent field or property of the map key of the entity that is the value of the map. The map key class annotation is not used when the map key is specified. Now we are considering mapping defaults for non-relationship fields or properties. If the type is a class that is annotated with the embeddable annotation, it is mapped in the same way as if the field or property were annotated with an embedded annotation. The annotation type embeddable in package jakarta.persistent in module jakarta.persistence specify a class whose instances are stored as an intrinsic part of the owning entity and share the entity of the entity. Each of the persistent properties or field embedded of the embedded object is mapped to the database table for the identity. If a persistent field or property other than the relationship property is not annotated with one of the mapping annotations, or equivalent mapping information is not specified in the XML descriptor, the following default mapping rules are applied in order. If the type is a class that is annotated with embeddable annotation, it is mapped to the same way as if field or property were annotated with the embedded annotation. If the type of the field or property is one of the following, it is mapped in the same way as it would if it is annotated as basic. Primitive Java primitive types, wrappers of the primitive types, java.line.string, java.math.biginteger, java.math.bigdecimal, java.util.uuid, java.util.date, java.util.calendar, java.sql.date, java.sql.time, java.sql.timestamp, java.time.localdate, java.time.localtime, java.time.localdatetime, java.time.offsetTime, java.time.offsetDateTime, byte array, char array, character array, enums, and any other type that implements serializable. It is an error if no annotation is present and none of above rules apply. Now we are considering entity relationships. If there is an association between two entities, one of the following relationship modeling annotations must be applied to the corresponding persistent property or field of the reference entity: one-to-one, one-to-many, many-to-one, and many-to-many. Annotation type one-to-one in package jakarta.persistent in module jakarta.persistent specifies a single valued association to another entity that has one-to-one multiplicity. It is not normally necessary to specify the associated target entity explicitly, since it can usually be informed from the type of the object being referenced. If the relationship is bidirectional, the non-owning side must use the mapped by element of the one-to-one annotation to specify the relationship field or property of the owning side. Annotation type one-to-many in package jakarta.persistence in module jakarta.persistence specifies a many valued association with one-to-many multiplicity. Annotation type many-to-one in package jakarta.persistent in module jakarta.persistence specified single valued association to another entities that has many-to-one multiplicity. It is not normally necessary to specify the target entity explicitly, since it can usually be inferred from the type of the object being referenced. If the relationship is bidirectional, the non-owning one-to-many entity side must be used in the mapped by element to specify the relationship field or property of the entity that is the owner of the relationship. Annotation type many-to-many in package jakarta.persistent in module jakarta.persistence specify a many valued association with many-to-many. Relationship among entities may be one-to-one, one-to-many, many-to-one, and many-to-many. Many-to-many relationships are polymorphic. If there is an association between two entities, one of the following relationship modeling annotations must be applied to the corresponding persistent property or field of the referencing entity: one-to-one, one-to-many, many-to-one, and many-to-many. For the association that do not specify the target type, for example, where generic types are not used for collections, it is necessary to specify an entity that is target of the relationships. Equivalent XML element may be used as an alternative to these annotations. These annotations mirror common practice in relational database schema modeling. The use of relationship modeling annotation allows the object relational mapping of the association of relational database schema or fully defaulted to provide ease of development facility. A relationship may be bidirectional or unidirectional. Bidirectional relationship has both an owning side and the inverse non-owning side. The unidirectional relationship has only an owning side. Owning side of the relationship determines the updates to relationship in the database. Following rules apply to bidirectional relationships. The inverse side of the bidirectional relationship must refer to its owning side by using the mapped by element of one-to-one, one-to-many, or many-to-many annotation. Mapped by element designate the property or field in the entity that is the owner of the relationship. The many side of the one-to-many or many-to-one bidirectional relationship must be the owning side. Hence, the mapped by element cannot be specified in many-to-one annotation. For one-to-one bidirectional relationships, the owning side corresponds to the side contain the corresponding foreign key. The many-to-many bidirectional relationships, either side may be the owning side. Relationship modeling annotation constrains the use of cascade equal remove specification. The cascade equal remove specification should only be applied to the association that are specified by one-to-one or one-to-many. One-to-many applications that apply cascade equal remove to other associations are not portable. Associations that specified as one-to-one or one-to-many support of an open removal option. Following behaviors apply when open removal is in effect. An entity that is the target of the relationship is removed from the relationship by setting the relationship to null or removing the entity from the relationship connection. The remove operation will be applied to the entity being orphaned. The remove operation is applied at the time of flush operation. The orphan removal functionality is intended for the entities that privately owned by the parent entity. Portable applications must override but otherwise not depend upon such order of removal and must not reassign an entity that has been orphaned to another relationship or otherwise attempt to persist it. If an entity being orphaned is detached, new, or removed entity, the semantics of orphan removal do not apply. If the remove option is applied to the managed source entity, the remove operation will be cascaded to the relationship target of the accordance with the rules. And hence it is not necessary to specify cascade equal remove for the relationships. Additional mapping annotations, for example, column and table mapping annotations may be specified to override or further refine the default mappings and mapping strategies. In addition, this specification also requires support for following alternative mapping strategies. Mapping of the unidirectional one-to-many relationships by means of foreign key mappings. Joint column annotation or corresponding XML element must be used to specify such non-default mappings. Mapping of unidirectional and bidirectional one-to-one relationships, bidirectional many-to-one or one-to-many relationships, and unidirectional many-to-one relationships by means of joint table mappings. Joint table annotations or corresponding XML element must be used to specify the non-default mappings. Such mapping annotations must be specified on owning the side of the relationships. Any overriding of mapping defaults must be consistent with the relationship modeling annotation that is specified. For example, if a many-to-one relationship is many-to-one relationship mapping is specified, it is not permitted to specify unique key constraint on the foreign key for the relationship. The persistent provider handles the object relational mapping of the relationships, including their loading and storing to the database as specified in the metadata of the entity class, and the referential integrity of the relationship as specified in the database by foreign key constraint. Note that it is the application that bears the responsibility for maintaining the consistency of runtime relationships. For example, for inserting that one and the many sides of the bidirectional relationships are consistent with one another when application updates the relationship at runtime. If there are no associated entities for multi-valued relationship of an entity fetched from the database, the persistent provider is responsible for returning the empty collection as the value of the relationship. Now we are considering bidirectional one-to-one mappings in relationship mapping defaults. This is an example. Annotation type one-to-one in package jakarta.persistence and in module jakarta.persistence specified a single valued association to another entity that has one-to-one multiplicity. It is not normally necessary to specify the associated target entity explicitly, since it can be usually inferred from the type of the object being referenced. If the relationship is bidirectional, non-owning side must be the mapped. You must use the mapped by element of the mapped by element of the one-to-one annotation to specify the relation field or property. Now we are considering here assuming that entity A references the single instance of entity B, and entity B references a single instance of entity A. A is specified as the owner of the relationship. The following mapping defaults apply. Entity A mapped to the table named A. Entity B mapped to the table named B. Entity A contains the foreign key to the table B. Foreign key column name is formed as a concatenation of the following: name of the relationship property or field of an entity A, underscore the name of the primary key of the column and name of the entity B. The foreign key column has the same type of the primary key of the table B. There is a unique key constraint on it. In this example, entity employee references a single instance of the entity cubicle. Entity cubicle references a single instance of entity employee. Entity employee is the owner of the relationship. Following mappings defaults apply. Entity employee is mapped to the table named employee. Entity cubicle is mapped to a table named cubicle. Table employee contains a foreign key to the table cubicle. The foreign key column is named assign cubicle underscore pk of cubicle, where pk cubicle denotes the name of the primary key. Of the table cubicle. The foreign key column has the same type of the primary key of the cubicle, and there is a unique key constraint on it. Now we are considering abstract key entities in inheritance. Example here, abstract class as an entity. Module annotation type inheritance in package jakarta.persistence in module jakarta.persistence specify the intended strategy to be used for an entity class hierarchy. It is specified on the entity class that is the root of the entity class hierarchy. If the inheritance annotation is not specified, though no inheritance type is specified for an entity class hierarchy, a single table mapping strategy is used. An abstract class can be specified as an entity. An abstract entity differs from the concrete entity only in that it cannot be directly instantiated. An abstract entity is mapped as an entity that can be the target queries, which will operate over and or retrieve instances of its concrete subclasses. An abstract entity class is annotated with the entity annotation or denoted in the XML descriptor as an entity. The following example shows the use of abstract entity class in the entity inheritance hierarchy. Inherit EMP ID but mapped in this class to ft underscore emp.eft EMP ID. Inherit version mapped to the emp.version. Inherit version mapped to the emp.address fk. Default to ft underscore emp.salary. pk column is pt underscore emp.emp ID due to the primary underscore primary key column, primary key join column underscore default. Single table per class hierarchy strategy in inheritance mapping strategies. In this strategy, all the classes in the hierarchy are mapped to a single table. In an inheritance type, the public static final inheritance type table per class, a table per concrete entity class. In enum inheritance type, in package jakarta.persistence, in module jakarta.persistence. In this strategy, the all classes in the hierarchy are mapped to a single table. The table has column that serves the discriminator column, that is a column whose value identifies the specific subclass to which the instance that is represented by the row belongs. This mapping strategy provides good support for the polymorphic relationship between entities and for queries that range over the class hierarchy. It has the drawback, however, it requires that the column that correspond to the specific state specific to the subclass be nullable. Now we are considering naming of database object. For example, assuming the use of English local, the following must be passed to the database as unlimited identifiers, so that they will be treated as equivalent for all databases that comply with the SQL standard requirement for the treatment of regular identities. Undelimited identifiers and delimited identifiers. The annotation type table in package jakarta.persistence, in module jakarta.persistence specify the primary table for the annotated identity. Additional tables may be specified using secondary table or secondary table annotations. The many annotation and annotation elements contain names of the database objects. I have assumed default names for the database objects. This is in this specification requires the following regard to be to the interpretation of the names reference to the database object. These names include names of the tables, columns, and other database elements. Such names also include names that result from defaulting. For example, a table name that is defaulted from an entity name or column name that is defaulted from field or property. By default, the names of the database object must be treated as undelimited identifiers and passed to the database as such. For example, assuming the use of English local, the following must be passed to the database as undelimited identifiers so that they will be treated as equivalent for all databases that comply with the SQL standards requirement for treatment of regular identified, unlimited identified, and delimited identifiers. Similarly, the following must be treated as equivalent. To specify delimited identifiers, one of the following approaches must be used. It is possible to specify that all database identifiers in use for persistent unit be treated as delimited identifier by specifying the delimited identifiers element within the persistent unit default element of the object relational XML mapping file. If the delimited identifier element is specified, it cannot be overridden. It is possible to specify on per name basis that a name for your database object is to be interpreted as delimited identifier as follows using annotations. A name is specified as a delimited identifier by the enclosing the name within double quotes, whereby the inner quotes are escaped. For example, you can use the table, the name, here the backslash, then double quotation, and again backslash double quotation here. When using XML, a name is specified as delimited identifier by using double quotes. For example, table name equal double quotation, ampersand quote, semicolon, customer, then ampersand quote, semicolon, double quotation. Now we are considering entity instance creation in entity instances lifecycle in entity operations. Entity instances are created by means of new operation. The entity instance are created by means of new operation, and the entity instance, when it's first created by new is not yet persistence. The instance become persistent by means of EntityManager API. Now we are considering pessimistic locking in pessimistic locking. The values of the jakarta.persistence.lock.scope property is defined by the pessimistic lock scope enum. Pessimistic lock enum pessimistic lock scope in package jakarta.persistent in module jakarta.persistence define the values of the jakarta.persistent.lock.scope property for pessimistic locking. This property may be passed as an argument to the method of the entity manager query and type query interface that allow lock mode for specified or used with a named query annotation. While optimistic locking is typically appropriate in dealing with moderate contention among concurrent transactions, in some application it may be useful to immediately obtain long-term database locked for selected entities because the often late failure of optimistic operations, such as immediately obtaining long-term database locked, are referenced as pessimistic lock. Pessimistic locking guarantees that once a transaction has obtained a pessimistic lock on an entity instance, no other transaction, whether transaction of an application using Jakarta.Persistent API or any other transaction using underlying resource, may be successfully modify or delete that instance until the transaction holding lock is ended. If the pessimistic lock is an exclusive lock, the same transaction may modify or delete that entity instance. When an entity instance is locked using pessimistic locking, the persistent provider must lock the database row that correspond to non-collection valued persistent state of that instance. If a joint inheritance strategy is used, or if the entity is otherwise mapped to a secondary table, this entails locking the rows for entity instance in the additional tables. Entity relationship for which the locked entity contains the foreign key will also be locked, but not the state of the reference entities unless those entities are explicitly locked. Element collections are relationships for which the entity does not contain the foreign key. Such relationships that are mapped to the joint tables or directional one-to-many relationships for which the target entity contains the foreign key will not be locked by default. Element collections are relationships owned by the entity that contain a joint table will be locked if the jakarta.persistence.lock.scope property is specified with the value of pessimistic locked scope extended. The state of entities referenced by such entities will not be locked unless the entities are explicitly locked. This property may be passed as an argument to the method of the EntityManager query or type query interfaces that allow lock modes to be specified or used with the named query annotation. Locking such relationship or element collection generally locked only the rows of the joint table or collection table for the relationship collection. This means that phantoms will be possible. The values of jakarta.persistence.lock.scope property are defined by pessimistic lock property enum, pessimistic lock scope enum. This specification does not define the mechanism of a persistent provider that uses the obtained database locked, and portable application should not try how pessimistic locking is achieved on database. In particular, persistent provider or underlying database management system may lock more rows than one selected by the application. Whenever a pessimistically locked entity containing a version attribute is updated on the database, the persistent provider must also update the increment the entity version column to enable the correct interaction with the application using optimistic locking. Pessimistic locking may be applied to entities that do not contain version attributes. However, in this case, correct interaction with application using optimistic locking cannot be ensured. Now we are considering entity listeners and callbacks, and in this an example and package annotation type entity listeners in package jakarta.persistence in module jakarta.persistence. We specified the callback listener classes to be used as an entity or mapped superclass. This annotation may be applied to an entity class or mapped superclass. The semantics of the lifecycle callbacks methods of entities, the pre-persist and pre-removed callbacks methods are invoked for given entity before respective entity manager persist or remove operation for that entity executed. For entities which merge operations has been applied and causes creation of newly managed instance, the pre-persist callback methods will be invoked for the managed instances after the entity state has been copied to it. These pre-persist and pre-remove callbacks will also be invoked on all entities to which the operations are cascaded. Pre-persist and pre-remove methods will always invoked as part of the synchronous persist, merge and remove operations. The post-persist or post-remove callback method will invoked for the entity after the entity has been made persistent or removed. These callbacks will be also be invoked in all entities to which these operations are cascaded. Post-persist and post-remove methods will be invoked after database insert or delete operation respectively. Those database operations may occur directly after the persist, merge or remove operations have been invoked, or they occur directly after flush operation has occurred, which may be at the end of the transaction. Generated primary key values are available in the post persist method. Pre-update and post-update callbacks occur before and after database update operations to entirely read data respectively. That these database operations may occur at the time the entity state is updated, or may occur at the time the state is flushed to the database, which may be at the end of the transaction. Note that it is implementation dependent as to whether pre-update or post-update callbacks occur when entities persisted and subsequently modified in a single transaction, or when an entity is modified and subsequently removed within a single transaction. Portable applications should not rely on such behavior. Post load method for an entity is invoked after entity has been loaded into the current persistent context from the database, so refresh operation has been applied to it. Post load method is invoked before a query result is returned or accessed before an association is traversed. It is implementation dependent as to whether callbacks method are invoked before or after cascading the lifecycle event is to related entities. Application should not depend on this ordering. Because status depend upon the non-transient context. Now we are considering enabling automatic validation in automatic validation upon lifecycle in bean validation. The validation mode element of the persist.xml determines whether the automatic lifecycle event validation is in effect. The values of the validation mode element are auto, callback, none. The default value validation mode is auto. If the application creates an EntityManagerFactory using the persist.create EntityManagerFactory method, the validation mode can be specified by using jakarta.persist.validation.mode map key, which will override the default whether the value is specified on the or defaulted on the persist.xml. The map values for this keys are auto, callback, and none. If the auto validation mode is specified by the validation mode element or the jakarta.persist.validation.mode property, or if neither the validation mode element nor the jakarta.persist.validation.mode property is specified, the bean validation provider is present in the environment. The persistent provider must perform the automatic validation entities or validation of entities. If the no bean validation provider is present in the environment, no lifecycle event validation takes place. If the callback validation mode is specified by the validation mode element and or the jakarta.persist.validation.mode property, the persistent provider must perform the lifecycle event validation. It is an error there if there is a no bean validation provider present in the environment, and the provider must throw the persistent exception. If the jakarta.persist.validation.mode property value callback has been passed to the persistent.create EntityManagerFactory method. If non-validation mode is specified by the validation mode element or jakarta.persist.validation.mode property, the persistent provider must not perform lifecycle event validation. Now we are considering fetch graph examples in fetch graph semantics, use of entity graphs to find query operations in entity graphs. The annotation type name entity graph in package jakarta.persistent in module jakarta.persistence used to specify the path and boundaries for find operation or query. The examples in here the only number attributes would be eagerly fetch. In this example here, the employee entity's primary key will be fetched as well as related project instances. Whose default fetch graph ID, name, and doc attributes. Will be fetched. Related requirements object will be fetched according to its default fetch graph. If the approver attributes large project were fetch type eager, eager that and if the any of the projects were instances of large project, the approver attributes would also be fetched. Since the approver attribute is employee, since the type of the approver attributes its employee, the approver default fetch graph ID name and employee number attributes would be fetched. Now we are considering type conversion of basic attributes. If the value of the auto-apply element of the converter annotation is true, the converter will be applied to all attributes of the target type, including the basic attributes values that are combined within other more complex attributes. The interface attribute converter in package jakarta.persistence in module jakarta.persistence. Class that implements this interface can be used to convert entity attribute state into database column representation and back again. Note that X and Y types may be the same Java type. The attribute conversion facility allows the developer to specify method to convert between entity attributes representation and the database representation for attribute basic types. Converters can be used to convert basic attributes defined by entity classes, map superclasses, and embeddable classes. An attribute converter must implement the Jakarta persistent attribute converter interface. A converter implementation class must be annotated with the converter annotation or defined in XML descriptor as a converter. The value of the auto apply element of the convert annotation is true. If the value of the auto apply element of the convert annotation is true, the converter will be applied to attributes of the target type, including basic attributes that contain within other more complex attribute types. Attribute converter classes in Jakarta environment support dependency injection through the context and dependency injection API CDI when CDI is enabled. Attribute converter class that makes use the CDI injection may also define lifecycle callbacks method annotated with the post contract and pre-destroy annotations. This method will be invoked after the injection has taken place and before attribute converter instances are destroyed respectively. Persistent provider is responsible for creating CDI SPI to create instances of attribute converter class, to perform injection upon such instances, to invoke their post contract and pre-destroy method if any, to dispose of the attribute converter instances. Persistent provider is only required to support CDI injection into attribute converters in Jakarta content environment. If CDI is not enabled, the persistent provider must not invoke the attribute converters that depend on CDI injection. Now we are considering shared caching mode element in caching. Whether the entities and entity related state of persistent unit will be cached is determined by the value of the shared cache mode element of the persistent.xml file. The shared cache mode element has 5 possible values: all, none, enable selective, disable selective, and unspecified. The value of all clauses, all entities, all causes, all entities and entity related state and data to be cached. The value of none causes caching to be disabled for persistent unit. Persistent providers must not cache if none is specified. The values of enable selective and disable selective are used to use conjunction with cacheable annotation or XML element. The cacheable annotation specifies whether an entity should be cached if such selective caching is enabled by the persistent.xml shared cache mode element. Cacheable element is specified on the entity class. It applies to a given entity and its subclasses unless subsequently overwritten by the subclass. Cacheable false mean that entity and its state must not be cached by the provider. Value enable selective enable the cache and causes entities for which cacheable true or its XML equivalent is specified to be cached. Entities for which cacheable true is not specified or for which cacheable false is specified must not be cached. The value disable selective enable the cache and causes all entries to be cached except for those cacheable false is specified. Entities for cacheable false is specified must not be cached. If either shared cache mode element is not specified in the persistent.xml file, or the value of the shared cache mode element unspecified and the jakarta.persistent.shared-cache.mode property is not specified, the behavior is not defined. The property provider specific default may apply. If the shared cache mode element in the jakarta.persistent.shared-cache.mode property are not specified, the semantic cacheable annotation and XML equivalent are undefined. Persistent provider is not required to support the use of second level cache. If the persistent provider does not support the use of the second level cache or second level cache is not installed, this element will be ignored and no caching will occur. Now we are considering cache retrieve mode and cache store mode properties. The cache retrieve mode property is the ignored for refresh method and always causes data to be retrieved from the database, not caches. Not the cache enum cache retrieve mode in package jakarta.persistent in module jakarta.persistent used as the value of the jakarta.persistent.cache to retrieve mode property to specify the behavior when data is retrieved by the find method or by queries. Enum cache mode is cache store mode in package jakarta.persistent in module jakarta.persistence used as the value for the jakarta.persistent cache.store mode property to specify the behavior when data is read from the database and when data is committed to the database. Cache retrieve mode and cache store mode properties may be specified at the level of persistent context by means of the EntityManager set property method. These properties may be specified for the EntityManager find and refresh method and query type query and store procedure query set hint method. Cache retrieve mode and cache or cache store mode properties specified for the find, refresh and query and type query and store procedure query set hint method. Override those specified and persistent context for the specified find and refresh invocation for the execution of the specified query respectively. If caching is disabled by none, the values of the shared cache mode element, cache retrieve mode and cache store mode properties must be ignored. Otherwise, the enable selective value is specified. The cacheable true is not specified for the particular entity. They are ignored for that entity and disable. If the disable selective value is specified, they are ignored by entities with the cacheable false is specified. Cache retrieve mode and cache store mode properties must be observed when the caching is enabled, regardless of whether caching is enabled due to the specification of shared cache mode element or enabled due to the provider specific options. Applications that make use of the cache retrieve mode or cache store mode properties but which do not specify the shared cache mode element will not be portable. Cache retrieve mode and cache store mode properties are jakarta.persist.cache.retrieve mode and jakarta.persist.cat store mode. Respectively, these properties have semantics and cache retrieve mode properties specify the behavior when data is retrieved by the find methods and by execution of queries, and the cache retrieve mode properties ignored for the refresh method and always causes data to be retrieved from the database, not the cache. Data store mode properties specify the behavior when data is read from the database and when data is committed to the database. Now we are considering entity type expressions and scale expression in conditional expression in query language. These are the you can see the examples. An entity type expression can be used to restrict query polymorphism. The type operator returns the exact type of the argument. The syntax of the type expression is as follows. The entity type literal is designated by the entity name. The Java class of the entity is used as an input parameter to specify the entity type. Now we are considering entity type interface in MetaModel API. Interface entity type type parameter x in package jakarta.persistence.metamodel in module jakarta.persistence. Instances of the type entity model represent entity types. Now we are considering entity in metadata annotation. This name is used to refer the entity queries. The annotation type entity in package jakarta.persistence in module jakarta.persistence specifies that the class is an entity. This annotation is applied to the entity class. Entity annotation is specified that the class is an entity. This annotation is applied to an entity class. The name annotation element is specified the entity name. If the name element is not specified, the entity name default to the unqualified name of the entity class. This name is used to refer to the entity inquiries. Now we are considering named entity graph and named entity graphs annotations. In entity graph annotations, the named entity graph annotation can be used to specify multiple named entity graphs for the entity to which it applied. The annotation type named entity graph in package jakarta.persistence in module jakarta.persistence used to specify the path and boundaries for the find operation query. Annotation type named entity graphs in package jakarta.persistence in module jakarta.persistence used to group named entity graph annotations. Now we are considering NTA listeners in persistent with default sub-element in XML overriding rules in XML object relation mapping descriptor. The entity listener sub-element define default entity listeners for the persistent unit. These entity listeners are called before any other entity listeners for an entity unless the entity listener order is overridden with the mapped superclass to entity element or the exclude default listener annotation is present on the entity or mapped superclass, so the exclude default listener sub element is specified within the corresponding entity or mapped superclass XML element. Now we are considering other sub element of the entity mappings element entity. The entity sub element define an entity of the persistent unit. It is undefined if multiple mappings files of the persistent unit contain entities for the same entity. The entity class may or may not be may or may not have been annotated as entity. The entity sub element and attributes of entity element overrides. The name entity graph in entity sub-elements and attributes. The name entity graph file sub-element is additive to any named entity graph annotation on the entity. It overrides any entity graph annotation with the same name. As an exception example, we can consider class entity not found exception thrown by the persistence provider when an entity reference obtained by EntityManager.getReference is accessed but the entity does not exist. Thrown when EntityManager.refresh is called and the object no longer exists in the database. Thrown when EntityManager.lock is used with the pessimistic locking is used and the entity no longer exists in the database. This is in the package jakarta.persistence and the module jakarta.persistence. This is end of my presentation, and thank you very much for watching it.